Okay, this morning we're going to get started with the additional clarifying comments. So hold on, Chris. Let me get you queued up here. Okay, our first speaker, or our only speaker, is Chris Williams with the International Lead Association. Chris, you will have 3 minutes, and there will be a timer there on the screen. Don't look at the other timer on the bottom. Look at the timer on the screen there, and it'll beep when you're done. Okay, go ahead.
Great. Thank you, Aaron, and thank you, EPA, for the opportunity to comment on the external draft ISA document. I'll be brief. I'll echo the comments that have been passed around yesterday about the ISA being impressive in terms of breadth and scope, but I wanted to point out that there are several dozen recent post-2013 ISA studies that were omitted, at least from the narrative sections of the external draft ISA. And a critically important omission is several papers published from what's known as the Study for the Promotion of Health in Recycling Lead. This study is one of the few US-based prospective longitudinal studies of a cohort of several hundred battery workers followed up over a 3-year period from their initial entry into the industry and starting with background blood lead levels. The study included state-of-the-art assessments of worker health status related to cardiovascular disease, neurological function, and kidney disease. Through 2021, 10 separate papers have been published in the peer-reviewed literature from this study cohort. These are critical papers for EPA to review and include in the external draft ISA, and a complete list of publications from the study, as well as a list of all the other post-2013 ISA publications omitted from the narrative sections of the external draft ISA, have been described in a detailed submission from ILA to the external draft ISA document docket. And for the benefit of EPA and CASAC, specifically with reference to the studies from the cohort I mentioned, those are available open access and also could be provided as a courtesy by ILA. So with that, thank you.
Okay, thank you. And I will note that we did get some comments both from the International Lead Association as well as the Association of Battery Recyclers and Battery Council International. We sent that out to you yesterday and also posted it on our website. Okay, Leanne, that's it.
All right, thank you. So we are going to pick up where we left off yesterday, where I think we're planning on starting with Appendix 12. And so I invite EPA to come up to the front and give us a brief introduction.
Great. Good morning. We are very happy to be back on day 2. This morning we are starting off with a brief reminder of Appendix 12, which is the process appendix for developing this draft ISA. And if we could go to the next slide, please. So Appendix 12 describes the process for developing this ISA in detail, and it builds on the 2015 preamble. to the ISA. The ISA systematically evaluates the literature and uses a weight of evidence approach. And some of the examples of how we systematically evaluate the literature include using scoping statements to define the parameters and serve as a guide for the literature search and strategy and for the inclusion and exclusion criteria for the literature. And examples of these are the PCOC and PCOS and LISI statements that are laid out in the ISA. The ISA, we also used a relational search and a keyword search to evaluate the literature. And we also used 2 levels of screening. We first started with a title and abstract screening for the literature, followed by a full text screening of the literature. And decisions about included studies are documented in our HERO and HAWK databases. HERO's our Health and Environmental Research online database, and our study quality evaluations for our select health studies are documented in HAWK, the Health Assessment Workplace Collaborative. And the process appendix also describes our study quality evaluation and causality framework, which is also further defined in the 2015 preamble. And I think that's all we wanted to provide about the process appendix.
All right, thank you for that introduction. So let's see, we have Appendix 12, we have 2 assigned reviewers. That's George Allen and Judy Chow. And so I think I'll turn it over to you, George.
Okay, thanks, Leanne. Good morning, everyone. I hope you're fully caffeinated or at least caffeinated enough. Appendix 12, the process for ISA development. Excuse me, the charge question is please comment on the clarity with which Appendix 12 communicates the process undertaken to develop the draft, the ISA. And basically this appendix clearly outlines the overall approach used for this ISA development. Figure 2-1, that's a diagram of the general process for ISA development, is a helpful overview. There's a lot of steps in the process. It was interesting to note the first 2 sections, and that's literature search and evaluation of study quality. These are critical steps given the huge amount of literature on lead that has to be parsed for this review. And my understanding is that in this case for lead, it's more difficult than for a lot of other more focused subjects because just literature on lead is all over the place with many different aspects of it. And if this review and selection and parsing is not done well, the ISA review document really won't be in good shape. It won't be adequate for its intended purposes. So these 2 steps, they're really important. They're critical. And they make up all but 4 pages of this appendix. I'm not saying that's a bad thing, but the rest of the steps get a relatively brief mention. And those include evaluation, synthesis, and integration of evidence. That's a really important piece. And the development of the scientific conclusions, and of course, the causal determinations. These are both really important steps, and maybe a little more detail could be put in there on them. But I don't want to underemphasize the first 2 sections because they are clearly critical, and that was probably more complicated than usual, as I understand it from this review. So just a couple other minor comments. Section 12.4, that's the relevance and scope piece. They're useful. It notes that we now have 3 different study inclusion criteria. We have the acronyms: population, intervention, comparison, outcome, and context. I understand that's pronounced peacock, more or less. not pycock or whatever. I don't know. That's for environmental research, which turns out to be atmospheric science, as I understand it. So the peacock is atmospheric science literature. PACOS, as we've heard before in the last year or so, is for health studies, and of course the biological piece, LISIs, for the welfare effects. So those are good structures. And they're all fairly new. Some of them are brand new to me. But in that same section for 4.2, that's the section on exposure, toxicokinetics, and biomarkers. For me, there's again some concern about geographic inclusion criteria, and CASAC has noted that in previous reviews this year and last year for exposure. That's only for exposure, not the tox or the biomarkers. And maybe this is something the panel could discuss further if it's of interest. And the same goes for, the PACOS used in 12.4.3, that's for the health effects and the other structures as well. But overall, it's well done and very, very informative and useful. Coming from someone who, for the most part, has understood the ISA structure for several years, it's still a good reminder that these are the pieces to it. And again, the emphasis on the literature search and review and deciding which studies bubble to the top for inclusion is critical to understand how that's done. So, and just a footnote here, HERO continues to be really great. It's a very useful tool for us as we do these reviews, both the ISA and the other documents. So that's all I have. And I guess, Judy, are you next on this one? Okay.
Go ahead, Judy.
Thank you. Good morning. I agree with George that there's a pretty good appendixes that deserve a little more details. That it is good that EPA set up the such called framework or scoping statement to get everybody confused with the PCAS, PACOS, and what do you call it? Leases, right? But however, I felt that the established criteria somewhat limited scope of the work, scope of the research, and may have omitted some valuable research that do not fall into the predetermined categories. So, and it is important, I understand it's a tremendous work like George mentioned, but we really need an unbiased comprehensive review. So for example, section 12.4.3.2 on epidemiology, the document specifically specify review articles synthesize a broad range of past studies that that review article that summarize all interpretation of existing studies rather than bring forward new information in the form of original research or new analysis. So therefore they excluded. I disagree with the statement because review articles synthesize really a lot of broad range of studies. They often point out the pros and cons of different study and they integrate the different information. And it should be considered as a starting point of the literature review. When I get my homework assignment, I typically search for the review article as a starting point. I hope EPA would consider that, not ignoring the review article. Some of the review articles are probably the best cited articles for many of the journals. Also, I find that choosing an exposure cutoff point concentration for different atmospheric whatever the ecosystem, and it to be kind of, sometimes they say it's 10 times higher than the guideline, but some other time just have a number. Those are embedded in the footnote of tables 12.3 and 12.4. So I find those cutoff exposure point, I think the Howard mentioned yesterday, it could be kind of arbitrary and I don't understand it. And maybe helpful if you put that upfront and rather than embedded in the just micro prints in the footnotes, and so that people can have an understanding of what level of contamination or exposure are we expected to. So that would be helpful. With respect to the welfare pack, Bill and Chris had some comments yesterday, but the Appendix 12 notes that exclusion publication, they will exclude publication of site-specific study at non-US locations. and those near the contaminated site. So that exclude a lot of places, a lot of the studies, such as the mine tailings and industrial effluent. The EPA's statement was that those high concentration, lack of connection to the air-related source or process. I feel that those are the important part. I think DJ mentioned, I'm not sure, one of the site became the Superfund site yesterday. Well, the site had a very high concentration. So those source orange sites, those especially tailing ponds or some mining operation, if they exist, may not have people, but they, like we are doing a study in Canadian oil sands. They need not worry about people. There are not many people, but they worry about the jack pine tree there. So it's just those contamination really affect the areas rather than for the ecosystem. Lastly, the section 12.5 on literature search and study. So that I understand there's a lot of work that George mentioned, that there's tons of, it is impressive. You have 28 articles you review, but not all of them are cited. But they did a period of 2011 to 2020, and then with a good update through June 2022. However, this ISA will not be finalized in 2023, and the standard will not be proposed or promulgated until 2026. So there's a big gap with the cutoff date, and with respect to the standard promulgation. I was wondering if EPA can consider amendment or some special addition or some kind of acknowledgement. I think Howard, someone mentioned yesterday, need to be considered, especially that public comment today. And Bruce sent me a whole bunch of some of the information this morning, so that there's a lot, some of the new information cannot be ignored. I was wondering if there's a way we can just sort of update, at least briefly mention, acknowledge, like George mentioned, this aviation fuel for the aircraft yesterday. I mean, it is coming soon, but it is in the queue, so that it probably worthwhile to somewhat to be acknowledged or addressed. Thank you.
Thank you. Any questions or comments from any members of the panel? I had a question based on George's comment about the exclusion, the geographic exclusion. You said is just for the exposure.
Yeah, I should clarify that. For the exposure piece, it says exposure studies pertaining to the US population and US-based lead sources were preferred. Studies were included from outside the US if these studies were judged to have important findings, with a focus on studies from Canada, Western Europe, and Australia. That's areas with study populations and air quality characteristics most similar to the US. So that's the detail on what that I did not cover. I wanted to put that out there. So that's actually what I'm referring to when I talk about that there may be some issue there with geographic constraints for that particular exposure topic.
Yeah, but that section, whatever, 12, and also on the welfare, they said they exclude all the non-US locations plus some kind of industry influence sites. That's kind of troublesome.
So are we suggesting that's problematic, or for both of those? I mean, George, you seem less clear on it than.
I don't know if it's problematic because I'm not sure, what wasn't included. I don't follow the lead literature as closely as I do ozone and PM. So it may be okay. I mean, I just note that that's, it's a fairly strict exclusion criteria, and that's something we've talked about in other reviews. I don't know if it's an issue or not, but I'll just toss it out there as something to at least think about and consider, and maybe look more closely at, but I'm not sure how we would do that. So.
But it's only excluded, you said, for the exposure and not for the health studies.
Right. Yeah. There's different exclusion criteria. Yeah. Gets a little complicated.
And then Judy, you're also saying that's also geographic exclusion for the welfare research.
Yeah.
Yeah.
I think that's problematic.
Okay.
I think it can be used as a references and so we learn what are the contamination, what the cause.
Okay. Bill, looks like you have your flag up.
Yeah, I just was following up a bit on my comments from yesterday. I apologize because I hadn't read Appendix 12 at the time, but I do have a couple of questions now that I have glanced at it. My comment yesterday about the inclusion of studies that didn't have measured concentrations in it, it actually is consistent with your text here, because it says one of the requirements for the evaluation of the test is, do analytical methods provide adequate sensitivity and precision to support the conclusions? And I would suggest that having no data, it doesn't do that. And that the other point that I thought was interesting is that it states that the main reason studies were eliminated were exposure concentrations that exceeded the cutoff concentration as specified in LESIS. And it goes on from there. But I guess I'm assuming from your comment yesterday that studies, I mean, a toxicological study by design is going to have higher concentrations as you go across them. And so I'm assuming that you would not drop a study that had a concentration, given the fact that the lowest value in the aquatic system was 10 micrograms per liter. That's pretty low. And most studies are going to go a lot higher than that. And I'm assuming you didn't drop studies that included that.
Yeah, that's correct. That we included, if the study had that as one of the exposure concentrations, we included it. So correct. Yes, we can make that clearer in the final.
Thank you. It was just, it was, as I read it, it wasn't clear in my little pea head as to how the cutoffs were actually used, especially in light of the design's going to go higher than that. But I do think that having analytical measured concentrations is critically important.
Anything else on, oh, Howard.
Hi, thanks. I'm going to make a comment. I'm not certain this is the proper place to make it, but it is a general comment on the on this the charge of the committee in writing a report. As we continue the research, one thing that I think is generally noticed is that we can't seem to find a threshold for a lot of these effects, for human effects. But at the same time, having served on, council for NIEHS and sort of been, also a continuing researcher, what I've seen is kind of a fatigue on funding-led research. And I think that what I think would be important, if possible, is to write the report and identify that where research is lacking. The absence of research does not mean an absence of effect. And the fact that we don't have research that has been able to look at, the really lower levels and do it really well suggests that we're still trying to understand what the full impact is of lead and, of course, all the other modifying factors and everything else. So, EPA has done this incredible comprehensive literature search. On some level, I think there's an opportunity here to, when writing the report, to say something about, well, there isn't that much research in this particular area, as a heads up for our research agencies, about what's lacking and what may need to be done. Because, most of the research now is just sort of piggybacking on other archived samples and, archived data. And there's very little funded new research being done in this area, at least in epidemiology.
That's an important comment. We typically have a charge question that looks at, asks for our recommendations about future research. Maybe that's more in the policy assessment review and not in the ISA review. We could certainly fold that into our comments here, and I would encourage where it would fit and write something to get it in the report. So. Oh, sorry, Mark. Go ahead.
It's all right. I just had a couple of minor comments on the document on appendix 12. So table 12.5 that sort of lays out some of the details of what went into this. Minor point that's came up, I think, I remember whether it was Brisa or Susan who might have mentioned something related to this on page 1224 when talking about epi and confounders. Race is in there as a confounder, and I mean, I get it, and I kind of know why that's done, but I think some language as to, this is not done because we think it's a biological thing, but it may relate to a lot of other social factors that could confound. So just a clarification point there. Another one in that same table, I think on 1225 at the top in the statistical methodology, and this, I alluded to this a bit yesterday, because this is one of the ones that another place where I saw it. The second line under epidemiology says, however, multi-pollutant mixtures models, i.e. models that include more than 2 pollutants, metals are considered to produce too much uncertainty due to copollutant collinearity to be informative. So it sounds like that's like a rule out, but I would not make that a hard rule out. I mean, it may be collinear and then you don't get stable estimates, but that doesn't have to be the case. And, and so it may not be as informative, but it would depend on the study. So I certainly wouldn't make it a hard rule out.
Thank you. Oh, Brian.
Good morning. Sorry, good morning. I'm trying to reconcile the ILA's comments with the approach that you took. And was there a cutoff year for the inclusion of health studies?
On the back end or the front end? Sorry. So the search goes back to where?
No, on the back end.
On the back end, yeah. 2022.
2022. So
June 2022.
June 20.
So some of the SVRL studies, the study for the protection of health and that works, whatever that is, some of them were 2022, 2021, 19. Did you include those?
I would have to look at the specific studies. I haven't.
I must admit, I did not know this literature, but they mentioned it. And so I felt it was incumbent on us to figure out what happened.
Yeah, we can look into it, but we also consider all the references that are brought up in public comment and also by CASAC.
Thank you.
Okay, any further comments or discussion on this appendix? George, do you have what you need to draft the response?
I think I do. Thank you.
All right, I think we're on to the next topic in the agenda, which is the executive summary and integrative synthesis. And so do we have a review from EPA on this topic as well?
No, not for this one.
Okay. And are you going to switch? Yeah, give you a minute then. right, so we have George Allen, Deborah Coruscant, Chris Johnson, and Brisa Sanchez for this. So George, do you want to start us off?
Sure. Do you want to do the executive summary first and then get all the comments on that and then do the integrated synthesis?
I will defer to you as the lead discussant, if
I would-
that's the way you'd like to do it,
Yeah, I would like to
please.
separate them, so we can,
Yeah.
do it that way. Okay. So for the executive summary, that's charge question 6A. Please comment on the clarity with which the ES communicates the key information from the draft led ISA. I thought the executive summary was very well written and very accessible to the casual reader or those who just want a quick high-level overview of the ISA findings. Context for findings that were based on the 2013 ISA versus studies since that ISA closed in 2011 is provided, and that's really helpful. What's new, what might change the process. References to additional detail in the integrated synthesis are given. And color-coded tables for causality determinations based on the tables in the IS are presented for both health and welfare effects, and important changes in categories are noted for both renal and total non-accidental mortality effects. Those are now both causal, that is a change. But it's worth noting here, as in the IS summary of causal determinations, that's table IS1, that the cardiovascular effects category combines 4 separate outcomes that were used in the 2013 ISA. And if you don't know that, you look at the table, and this applies to the table in the integrated synthesis as well. I'll talk about that in a bit. You'd say, whoa, causal, new, and that's not really the case. It's a reshuffling of the deck a bit. And so that I know at first confused me, got my attention, and I know talking to other people on the panel, it confused them too. So, and I don't think it's noted in that table there. It's buried, it's further down in the material, but that might be useful. I'll come back to that in the synthesis discussion too. Figure ES1, that's a useful diagram of the conceptual model of multimedia lead exposure. And that's a critical piece for this review because lead is complicated. There's lots of ways to get exposures. Some of them count, some of them don't for this review. Section ES5 clearly explains the important point that these exposures are considered air-related if lead passed through the air compartment, excuse me, at any point prior to plant, animal, or human contact. And I think that's a really important phrase that really defines what we're looking at here. The summaries of the 2017 NEI data presented here, I think it's probably already on your list that they will need to be updated to the now released a month or so ago, 2020 NEI data. And of course, they now include wildfire lead emissions, which in new category, but it turns out it's 3% of the total, and I believe that's the 4th highest category. So it's, as we've recently experienced, wildfires are becoming more common, and there's lead in them. Oddly enough, we're actually doing some wood stove emissions characterizations, and lead has bubbled to the top of our attention on that one as well. So it's not just wildfire wood smoke, it's wood stove wood smoke. Another important finding is summarized in section ES 611, and that says recently available evidence does not provide evidence of a threshold for the observed neurodevelopmental effects across the range of blood lead levels examined. That's ES 713, where that's presented. That's I think an important point. section ES7. That's key aspects of health and welfare effects evidence. I think that's a good summary of conclusions on the key policy relevant topics in the ISA. And there was a charge question 6B about recommendations of anything that should be added or removed. And I don't really have anything to say on that. Overall, I thought it was a pretty good and complete summary of the text and the integrated synthesis. And I guess on to the other panel members. Debbie?
Yeah, hi. I don't really have anything to add. I think that was a great summary. I just would point out that I think the inclusion of the key aspects of health and welfare evidence is important. It does belong in the ES. So.
Thank you. Chris?
George, are we covering both 6A and 6B now, or? Yeah. Okay. Sure. So as far as 6A goes, I took that very, very narrowly. Comment on the clarity. It is very clear. It's a really wonderfully written section. So that part's easy. The second part, information that maybe could be added or removed. I have a somewhat different opinion than George does about figure ES1, the so-called Venn diagram. I think for someone who's approaching this document, the first thing that they see is that diagram. I think it's somewhat difficult to navigate through. There's not a lot of narrative provided to help the reader understand what's in the document. If you think that it's really not a Venn diagram, it's a conceptual model. If you think it's important to have that in there, you might want to think about maybe a I don't know, professional artist pull something together that's a little more easy to follow and visually appealing. So as George mentioned, the causality tables I think are excellent, clear, helpful. I think for someone who only reads the executive summary of this document, I think they really do a great job for that person to really understand the nuts and bolts of what the ultimate analysis is trying to say. So I think those are, to me anyway, those were the real need and the real key to this section. There's a sentence that occurs on page 17, lines 7 to 10. It also occurs in the integrated synthesis. I believe it also occurs in one of the appendices. I think Bruce actually may have been referring to this yesterday in one of his comments. The sentence reads, in other words, in older studies in which leaded gasoline or local sources were a major contributor to air lead, there may be a greater likelihood of discerning the true effect of air lead on blood lead due to relatively less contribution from non-air exposure pathways. I understand what that's trying to say, and certainly from a kind of a conceptual and statistical point of view, it makes some sense, but it concerns me in the sense that here we are trying to advise EPA on how to set a national air quality standard for for the conditions that exist now, which are not those conditions in which elevated lead in gasoline created higher concentrations and less of a mixed media sort of approach. So I don't know the extent to which this shapes your thinking in terms of assessing and analyzing the data. In other words, whether taking this out would actually substantively change how you view. I have a hard time imagining that it would, but I think that that's a little bit of a red herring in terms of people in a certain direction that isn't really all that relevant to what you're trying to do. Finally, on page 17, where you discuss the air lead to blood lead relationship, you make the point that the slopes of those relationships tend to be greater at lower values of the independent variable. I'm thinking in the back of my head about the IRP that we're going to discuss in a little while. So, this may play into that discussion too. But I wonder if it makes sense rather than trying to look at piecewise linear models in terms of understanding that changing slope relationship, whether, developing a modeling approach that's nonlinear by its nature would be an appropriate way forward. So those are my comments.
Thank you. Brisa?
Good morning. Really, really a well done job in that executive summary. It was easy to follow, and I appreciated, after all the discussion yesterday, the hard job that it is to bring it back up to the really big picture. I have more of in terms of the clarity, I had a little bit of a point of confusion. I noted that section ES 6.1 on human health and the welfare section ES 6.2 follow distinct structures. One of them is organized by life stage and the other one by specific effects. And I guess I kind of came to conclude that potentially a reason for that was to avoid some repetition, but it just struck me when you look at welfare, you go through reproductive effects, neurobehavioral effects, but when talking about human health, it's divided into life stages. I don't think I was just curious what kind of led you to that. And in terms of any information that could be added, I think that it would be helpful in section E.5 between pages ES6 and ES7 to include some information regarding exposure disparities. And these passages talk about exposures trending down. But I think the fact that disparities remain in exposures would be useful to note, especially because later when we talk about at-risk populations, it would be useful to have that already stated. And then similarly around that same passage it would be, I think, useful to insert a fragment of a section related to the fact that place factors also drive blood lead levels. So there's a sentence that says, blood lead is dependent on recent exposure history of the individual. It may be useful to right there add something about how that exposure history of the individual is tied to the place where those individuals live. And again, that kind of will tie down nicely to later sections where you talk about at-risk populations.
Thank you. Any other comments about the executive summary, Susan?
Yeah, I mean, I'm sorry to perseverate on this, but the comment on ES 17 that Chris and yesterday Bruce talked about, I mean, Bruce said he read it 10 times. I probably read it 20 times. And actually, you said you understand what it means. I actually don't understand what it means. So I think, I can't, and I think it's really distracting. But I also think there's potential information in there that's really provocative. And the way that the issue of slope factors increasing with decreasing air lead being attributable to the potential for, I guess, measurement error to have played a role in the past when there were more sources contributing to blood lead levels. And now that there are fewer sources, the slope for the air to blood lead is steeper. It doesn't completely make sense to me, because if it's a measurement error issue, it doesn't necessarily change the slope. It may change the precision. So I think the more fundamental thing embedded in there, and as I said, I read it a lot and I still don't completely understand it, is that there may be something that occurs at lower air lead levels. Maybe a larger proportion of the lead is smaller particle size, or there's something that's occurring as air lead levels go down that enhances uptake. And that's how I would interpret this. And that raises a whole another set of issues which may not be answerable with existing data. But I do think embedded in that paragraph are a lot of possibilities that are potentially really confusing. So thinking about its role in the executive summary and whether you want to go down that route or not would be helpful. So.
Thank you for that. Mark.
Yeah, thanks. So just a couple points. In ES 611, I think that's page ES 9. There's a statement that notably evidence suggests that some lead-related cognitive effects may be irreversible and that the neurodevelopmental effects of lead exposure may persist into adulthood. And it cites the prior, or so maybe it's the prior ISA 2013. I'm not actually sure what's being referred to, and maybe that is the case, and certainly biologically there's rationale to think that could potentially happen. I just wanted to be clear that, because I know that the newer studies saying, like out of Dunedin and other places, saying the exposures, you still see effects later in life. Those clearly say that you can get effects later. I don't think they necessarily prove it's irreversible, because we don't kind of know what's going on. So I just wasn't sure what was the data suggesting it's absolutely irreversible. I do think there's biological plausibility for that. I'm just not sure what epi studies would actually really directly address that. Again, it's a scenario of kind of absence of evidence doesn't mean evidence of absence kind of thing. Then also, I think there's just a misclassification in that table on ES 20. Unless I'm misinterpreting something on the human health effects, 1, 2, 3, fourth bullet down, where it talks about the ones that are likely to be causal relationships. You have total mortality in there, but I thought that one was causal. Yeah. Okay. Sorry, one more. There's also a statement in IS. Oh, we're not on the IS yet, right? I should hold off on that. Sorry. Okay.
So were you talking about page ES 20?
Make sure I didn't go in the wrong.
I don't
There
think
is not
no.
one.
You had wandered into the IS.
Oh, sorry, I
You're,
wanted
you're in
the
the
IS.
IS.
My apologies.
We'll come back to that.
Okay. That helps. Any other comments for anyone? Oh, Susan.
Yeah, just to expand on what Mark said, the notion of irreversibility of early life exposures and their long-term consequences. I mean, there are a number of studies, both in animals and humans, that suggest that the consequences of childhood lead exposure and childhood-related neurodevelopmental problems can be largely overridden with environmental enhancement or, sort of resources that are provided to the kids. So there's some evidence, maybe reversibility is not quite the right word, but you can no longer discern lead-related changes in children or animal behavior and development after intervention. So irreversibility is probably a strong word.
Just to follow up on that point, and I don't know whether, Susan, this is our trend, don't have to go deeply in this conversation,
Yeah.
but I do have those studies in mind, and that's partly in my head. But what I'm not sure about even those studies is whether it addresses reversibility, or it just says that if you have those enriched versus you have a bad effect of lead and then you give the enrichment and that can reverse it. I don't believe the studies do that.
Well, a lot of them do the interventions after there's been demonstrated deficit.
They do. Okay.
Yeah,
Okay.
but I think the issue is because of the complexity of measuring neurodevelopment. Reversibility may be too strong a term.
Yes.
You no longer can ascertain, there may be some compensatory mechanisms that are at play that cover up the discernible
Right,
neurodevelopmental
right.
issues, but it doesn't mean that there's not
That the fundamental
changes,
biological
fundamental
damage
changes.
is.
Yeah, but we don't
reversed.
have enough
Yes.
literature to answer that question. Yeah.
Perry. And then Howie.
Yeah, I had several points I wanted to make on the executive summary. I think, this is a huge document of 2,000 pages. And so this part, I think, is particularly important because probably 90% of readers will just focus on this first 20 pages. And I felt that it was not well organized in terms of getting the message out. It was maybe better organized about, presenting what you did over this project and putting all of this together. But I think the important message here is not what you did to make it happen, but what it says ultimately. And I think to me, some of the most important points are either not here or buried away. So one issue for sure, I think, is regarding exposures and the discussion of exposures. And this is also, I mentioned yesterday in a couple of other places that there's been some, language used here like primary and secondary exposure sources. I don't think that that's something that that's the kind of language we want to use in regards to the remaining both the airborne exposure sources and other exposure sources, because these are shifting. And as we're looking at lower population blood lead levels, the smaller sources contribute overall to blood lead levels and become more significant over time. I mean, ironically, as we're looking at lower levels, it's not one big exposure that is creating the problem anymore, like gasoline, but now it's a whole mixture of exposures, each contributing a small proportion to the overall body burden. And I don't see that kind of a discussion here. And I think it's important to point out that that this is kind of a shifting as we eliminate some sources, other sources become more significant. And I think it's important to note that up front and try to get away from calling, sources the most significant or primary and secondary. And I think we need to be very careful about that. Also, the discussion can benefit from pointing out that, as the US reduced exposures from certain sources, others, rise to the top. So for example, as we reduce industrial emissions in the last decade or so, avgas, aviation fuels become a larger contributor to airborne concentrations. But it's important to also note that, that's happening at the same time that the consumption of aviation fuels has not gone up, it's actually gone down a bit. So I think, it's important to put these things into perspective. Also, I think that some of the most important health findings are buried here. And I mentioned yesterday in particular, what I think is significant about this review versus the one 2013 review is the growing data around mortality. And as a result, I think that should be called out, and it deserves its own section. There's not too many environmental contaminants that have this kind of health endpoint that is so clear cut in the case of lead. I mean, you could talk about IQ points, and you could talk about all these other health endpoints that are maybe not as weighty as mortality. And, there aren't many, and there aren't other metals that have that kind of a clear mortality pattern. And the cardiovascular risks here, if you look at them compared to some other well-known cardiovascular risks, like obesity and smoking and so on, these stack up there right with the top. And that message is not in the executive summary. And I really think that should be highlighted here as well, and certainly separated from the other discussion of other organ systems and not buried away like that. Ironically, I think in terms of the exposure situation, I thought the clearest the clearest language on that was buried away in the Appendix 12, where there's a very clear-cut statement I'd like to read. It's on in section 12.4.2. And it says that studies containing lead concentrations in other media, soil, dietary sources, consumer products, occupational sources, and ammunition were included because cumulative body burden can occur as a result of contributions from multiple exposure pathways. e.g. ingestion of lead-containing soil by children. And the origin of lead can be difficult to determine as stemming from air-related sources. So I think that's, something that should be right up front and not buried in the very back. I mean, the fact that airborne sources relate to other environmental sources, but that it's also very difficult to tease out the airborne, the portion coming from airborne emissions. And I do think you discuss it in the current draft, but it's much more nuanced than it is in that in the case that I mentioned. Then a couple of smaller points I see in 7.4.2, it discusses proximity to lead sources. I think this is confusing. It's important that that be clarified because I think you're talking about proximity to airborne lead emissions, not lead sources. And there's also on table IS 13, you have a category of residential factors. I don't know what those are, but I think
It's sorry to interrupt, but do you want to wait to your integrated summary synthesis comments? Do you want to wait till we get to that section?
Oh, okay. We're not there yet.
We're focused on the executive summary.
Oh, I thought this was in the executive summary, but I'm
Oh,
mistaken.
okay. You said table IS 16. or
13.
13. So
That's not there.
IS is the integrated.
Oh, sorry. Okay, then I'll wait.
yeah, not to interrupt, but is that it for the executive summary in your
Yes.
comments?
Yeah.
Okay, thank you. Yeah, and it's important to get back to it. Howard.
Thank you. These comments build on what Mark and Susan and Perry have said, but I want to draw your attention to the fact that figure ES2, which, and as Perry said, most people are just going to read the executive summary, does a very nice job of summarizing the evidence, whether it's likely causals, et cetera, but it doesn't really address the dose response or the issue of whether there's a threshold for any of these effects. And I would just draw the attention to the contrasting this with the 2012 NTP monograph on lead, where in table 1.2 in the, right up in the executive summary, they have this table where they go over the neurologic, immune, cardiovascular effects, the NTP conclusion as to whether the evidence is limited, sufficient, or whatnot. But then they actually go over the blood lead evidence and sort of what's the level at which you see these effects. And I think, given that the NHANES data shows that US population levels now, whether geometric mean is at 1 or below 1 microgram per deciliter, coupled with the fact that we haven't been able to really find a threshold for a lot of these effects because we haven't really done the research, coupled with the fact that, there's a sort of popular conception. And when I talk about this search, people say, well, aren't the NHANES blood leads, like below 1? So who cares anymore? It's actually 10 micrograms per liter. And it's still, as Bruce says, it's 10 to 100 times greater than what pre-industrial man has. So why would one expect that the effect just disappears at 1? So, there's a lot of practical interest in understanding whether there's a threshold for these effects. And I think this document has the opportunity to counter the general impression out there, including in the scientific community, that, well, once you're down to 1, it's, who cares? Well, maybe this table should include some discussion of what on the threshold evidence is, sort of like what the NTP did. And I guess my question for the EPA is, you probably thought of that. Why wouldn't you do what the NTP did in its 2012 document?
So is that a question you wanted to ask EPA?
Yes.
Yeah, thanks. So I'll put EPA on the spot.
Well, I think for some of those issues in terms of like the levels that we're seeing effects, we do try to communicate in the integrated synthesis and the summaries of the health effects. I think your point is well taken that we could maybe pull some of that up into the executive summary in terms of what NTP does. Obviously, we're creating a sort of a different document, and it's something, of course, we can consider. We weren't modeling though our assessment after that. Anything else?
Okay. Further comments on the executive summary? George, do you think you have what you need for the executive summary?
Yeah, I think I have a lot to work with here.
Okay. Do you want to lead us through the integrated synthesis now?
Sure, well, I can do that. So for the integrated synthesis, charge question 7A says, please comment on the usefulness and effectiveness of the summary presentation in the IS and provide any recommendations or alternate text that may improve the synthesis of available information across subject areas and the communication of key findings. Well, in the new structure of the ISA, well, it's relatively new. It's not the first time, but I think it may be the second time. As EPA's ISA charge letter says, the executive summary and the integrated synthesis serve as the main body of the ISA. The integrated synthesis is it's a more detailed synthesis of the ISA's most policy relevant scientific findings. I'm taking that. Those are not my words, that's a quote, but it's true. It is well written. I think it's well written and organized. And at about 100 pages, it has more detail than the executive summary, but less detail than the appendices. So it's a good middle ground. The IS mostly references the ISA appendices instead of individual literature sites, and I think that's fine if people want, it points you to where they are, and if you want the more detailed references, you can go get them, and I think that's appropriate. Kind of keeps it from getting too cluttered. For each causal category, each section ends with a very useful comparison between the evidence from the 2013 ISA and this ISA. That shows what evidence is new in this review, which, as I noted earlier, that's critical to understand. Overall, I find it a very useful and effective approach to present the more detailed findings of the ISA. Overall, there's I think this is something that Mark picked up on. The overall conclusion page, that's IS1, has total mortality under the likely causal category. I think that's just a typo. So table IS1 groups total mortality under effects on other organ systems, and that's actually consistent with the order stated in IS 122. That's the organization of the ISA on page IS-7. But figure ES2, it's the companion table, more or less, in the executive summary, lists it as a major separate category after the effects on other organ systems. Now, I don't know if that's a typo in ES2 and it just got kind of separated out by mistake, or is it meant to be in the ES table? Is it meant to be in the same structure as the IS table? Either way, they're not consistent with each other, and that's something that is worth looking at. It could be that it's right after all the other organ systems, and maybe there's just like one extra line in there that shouldn't have been in there as a major category. So the total non-accidental mortality is a major category in ES2, and if you just simply remove that, it would be consistent with the other table. So either way, but that's something that needs to be resolved. And as noted with the executive summary discussion, the new category with a plus on it in this table for total non-accidental mortality is confusing to the casual reader, or even the not so casual reader perhaps. And as I said earlier, it's new only in the sense that this category consolidates previously separate categories, primarily, but not solely, cardiovascular mortality. And that is explained in section IS 739 mortality, which says the 2013 lead ISA evaluated studies of all-cause mortality together with the studies examining cardiovascular mortality. And these studies were included within the CVD chapter. So this is a change in how mortality is presented. And it really needs to be noted in those tables, in the footnotes or somewhere where it's really clear that, okay, this is new, it's causal, it's got a little, it's dark purple or a plus sign, but a lot of it really isn't new. And that's really important to communicate here. So that's not hard to fix. I think for the rest of the charge questions, 7B, C, and D, I would have to rely on panel members that have carefully reviewed those relevant appendices. I can't state whether the material in those appendices is reflected properly in the synthesis or not, because that would be a 2,000-page read, and that's just not going to happen. So those are my comments, and we can go on to the rest of the discussions for this. Thanks.
Yeah, thanks, George. And I think I neglected, I was going to mention yesterday for people who had the opportunity to read this part of the integrated synthesis where they also reviewed the appendices. It would be really helpful.
Yeah, you actually did note that.
Oh, I did know
midday,
that.
yeah.
Good.
So you're off the hook.
Okay. Yeah, well, there's not been much time for that. So we may need to also follow up as we're writing the consensus comments. So Debbie.
Yeah, I agree. This is a generally well-written section. I too thought that the comparisons of the 2013 versus the 2023 ISA basis were very helpful. In terms of sort of summarizing where you were going, I thought that the available evidence was well synthesized for the concentration response relationships, as well as for the timing of lead exposure as it contributes to the nervous system effects. One of the things I did like, and I know there's a lot of difference at EPA in terms of this, is I thought it was particularly important to include the discussion of populations at increased risk and other factors out there so that we begin to move the discussion more towards cumulative risk. And I know that can't happen here, but this one chemical at a time thing is so 20 years ago, but I know we can't do it there, but maybe even a statement about these are important because they may, and you do discuss some of this in some of the appendices, but that some of these other risk factors may in fact enhance the effects of lead. And so it's really all about cumulative risk. That's why, to me, those sections are so important actually in the collective evidence. So those are my comments.
Okay, thank you. Chris.
So sorry to belabor this, George, but are we talking about all four charge questions here or just the first?
All four, if you wish.
All right. So I think that in terms of the readability of this chapter, I think it does a very good job of being accessible to a knowledgeable non-expert. So as someone who's a soil scientist and an ecologist reading the health effects sections, I thought I was very accessible. So I think it's very well done in that regard. The last paragraph of section IS4, which is on page IS 17, discusses techniques, including models that are used to estimate lead exposure. So the IE-UBK model, and then the coupling of that with the stochastic human exposure and dose simulation, and then also this all ages lead model. I left that paragraph wondering if there was anything that could be added in terms of what those different models say about the likely importance of different lead sources, and just, not results from, but just like where those models take you, how those models take you in different directions, potentially. Section IS 7.2 includes figure IS2, which is a generic figure illustrating health effects pathways at the organismal and population levels. The rest of the IS doesn't include any of those diagrams, nor does the text in the section drill down to the level of the boxes and arrows that are in it. So I don't really see much of a reason for that figure to be in the integrated synthesis, even though it's a useful tool that's used in the appendices. I guess you could ask, well, where else then would we just, have it, introduce it? But if it does need to be in the integrated synthesis, I think there needs to be some explanation about what it's trying to do. As far as concentration response relationships and exposures and things like that, I like with the executive summary, I think the summary tables that are IS2A to IS11 are essential, informative. Again, as someone not focused on health effects, I found them very easy to navigate as along with the associated text. Walking into some waters I'm not that familiar with. I did, in reading one of those sections, the assessment of internalizing behaviors in children, that's section IS 7.3.1.4. I was left kind of puzzled that the causality determination wasn't upgraded in that particular case to causal. Now, we talked about that section before yesterday, and I can't remember if that particular causality determination was discussed then. But in any event, if the text could reflect what was lacking to possibly change that causality determination, that would be useful. IS 9 addresses our understanding of air lead to blood lead ratios and concentration response relationships. The summaries are concise, well done. But I wonder if it might be useful to have one or more graphs pulled from the appendices into those sections to give the reader sort of a sense of where the data support the discussion of the nature of those relationships. I mentioned that in our discussion of the executive summary. The section IS 9.1, which reviews air lead to blood lead relationships, it ends kind of equivocally without making any kind of declarative statements about what our best current sense is of what is, at the end of the day, probably the key policy relevant relationship in the whole document. So I don't know, is this some sort of like sense of where we stand with that particular issue would be good in the integrated synthesis. What else? In terms of the discussion of populations at increased risk, the synthesis does a good job in synthesizing that information. As someone who is not an epidemiologist, I'm happy to be corrected or otherwise, have people chime in. But some of the quote unquote populations that are described there don't strike me as populations per se. For example, nutrition, stress, other metals, maternal self-esteem, cognitive reserve. Again, I'm not an epidemiologist, but they don't strike me as defining at-risk populations per se in the way that other categories there do. They are sort of, to me, they strike me as sort of amplifiers, factors that might amplify the effects in particular populations. So again, I'm happy to hear other people disagree with me, but that was something that struck me. And then finally, in terms of the ecological effects section, I thought, having read that that appendix carefully. I thought the integrated synthesis did a marvelous job of really hitting the high points of that. And I really have no suggestions for improvement at all in that section.
Thank you for that, Brissa.
Thank you. I'll continue actually with Chris's comments on at-risk populations. I agree about some of the labels are, exactly the same comments. And perhaps one way to address that without having to kind of redo or reframe things might be to wordsmith some of those labels. So instead of nutrition, talk about poor nutritional status or things like that. That might be useful. Although I'm not sure that you can really do that with all those variables. I'll next talk about the integrated synthesis box in page IS1, right? This is like the very nice box at the beginning of this section. In light of the panel's discussion yesterday on female reproductive health and also Bruce's comments, Suzanne, Dr. Corrick's presentation on female reproductive health outcomes, I think that panel, that box might need to highlight those effects more prominently, as well as the birth outcomes discussion that we had. I think Bruce contributed additional citations for those comments. So you might need to reconsider the synthesis in that box. It's still related to that same box. I like to highlight that you did a really good job later down in the text, talking about at-risk populations or at-risk groups, in particular minoritized children. But the last bullet within the health effects if the synthesis box may need to be a little bit more explicit about separating health effects that are due to higher exposure and populations that are at higher risk because of higher exposure versus higher sensitivity. And it's clear to me that it's an issue of synthesizing what you have already described. And so here, I think it may be useful to talk perhaps more generally in that bullet. The bullet currently talks about many populations, example, race, ethnicities, and genetic backgrounds in life stages, example, children and adults have been shown, so on, so on. I think it may be useful to simply say many population subgroups in life stages have been shown to be at increased risk of health effects associated with either higher exposure or higher sensitivity to exposure. And I know that in the text prior, you make that distinction that at risk means many different things, because the literature has been kind of not very clear on this. But because this box is probably one thing that people will focus on, it may be useful to make that explicit, differentiation. And then after that, you can then continue on with, the populations in life stages evaluated. And then once you're listing out the specific subgroups, then that's where you can bring in minoritized populations rather than currently stated in the same parentheses. You have race, ethnicities, and genetic backgrounds in the same parentheses. That might, lead less informed readers to conflate the two. This along the same vein of at-risk populations in IS6 pages, IS19 lines 6 to 7, I think it would be again useful to talk about what the gap in exposure is between minoritized children and white children. And then finally, related to minoritized populations, to at-risk populations, table IS12 you talk about one of the factors in table IS-12 is residential factors. And the evidence that you summarized in the exposure appendices showed compelling evidence that residential segregation is a specific factor and that's associated with higher lead exposure. And so in that box, in that table, the row on residential factors, it may be useful to be more explicit about what particular residential factors are being discussed. I think that would add clarity, and also clarity that has potential policy relevance. So that's great. I'll move on to 7B. 7B asks us to consider the concentration response relationship and how that was explained, and also the timing of lead exposure. And I agree with the conclusions on section IS 9.2 that the effects are larger at lower blood lead concentrations, and that this is consistent with nonlinear exposure response curves for nervous system effects. And I also agree that among adult studies, it's challenging to precisely disentangle the health effects in relation to timing of exposure because of this mobilization of lead from bone to blood and so on, and that studies among children are more informative in helping us ascertain exposure windows. Although, the exposures among children also are correlated across timing and so on, but the studies among children are more indicative of or more helpful in determining exposure windows. I think some of the comments that I've made here echo what Howard has been telling us all along regarding, going lower and lower in the exposure range. And I think that, speaking to the nonlinear exposure response curves really helps to understand those higher effects. I think the only, yeah, I'll stop there. It's good. And I don't have any other comments on the other two questions. I think there were. Yeah, I've already either talked about them already or have no more comments.
Thank you. Perry, did you want to come back to your comments that you wanted to make on this?
Yes, I think I can. I as you noted, I dived into this earlier than, but to go back to it, I think on the table of IS 13, I was confused about residential sources and residential factors. To me, that should clarify whether you're talking about, homes with lead-based paint or homes contaminated with lead, soil, or dust, etc. I think that's what you're really getting at. I just thought that was unclear. And I had one final point on this section on when you discuss blood pressure effects in 7.4.2.1. It says these racial differences may also reflect the history of greater exposure to lead among non-Hispanic Black populations. This is confusing because it seems to contradict the conclusions presented of consistent findings of greater effect in African Americans. So I think there's just some confusion in how that paragraph was written, and I think it's a key point that needs to be clarified. Thanks.
Mark.
As the other one who wandered into the IS a little early, I'll come back to some of the points. The first one, I guess, is also hitting on that point that Perry was just mentioning about the race issue. I mean, so I totally agree with what he's saying. And there is this, I think we do need to be careful between where we are on the, whether there's a different slope of a relation versus we're just somewhere else on the exposure spectrum. That's an important point. But then also to sort of also hit on what Brissa, I think, was talking about, and I'm noticing it here in that IS1 table where the populations, e.g. race, ethnicities. I mean, I think just to reiterate that it's probably worth going through the whole thing and making sure wherever kind of race, ethnicity is talked about, that we're very clear about this not being a biological issue, but there are all sorts of contextual factors around different populations, like systemic factors that are probably at play here rather than making it sound potentially like a biological thing. So I think we have to be very careful about that language throughout. The other points I wanted to get at in here. So on page IS8 at the very top, where it sort of talked about the causal, evaluation of the evidence, and it's this comes up, I think, in other places too, but this is where I sort of noticed it about how you're looking at causation, not just association. These are based on judgments of 9 aspects of the evidence, et cetera, which is, I think, clearly referring to Bradford Hill kind of criteria, which are important and foundational in many ways, but also kind of guideposts. And I think if that is what this is generally referring to, it's a little bit old school, I guess. And so I think some reference to the idea of kind of assessing absence or attempt to mitigate biases as a sort of general framework would at least advance it a little bit into sort of slightly more current causal language thinking. And I don't know if that came up in other places as well, but then I had another question on IS36, page IS36 in 7321, cognitive function in adults. Line 10 talks about the potential for residual confounding by age. And I might have missed this. I mean, my general thinking, and Brian can weigh in on this too, is at least in the adult literature, I mean, I think most of the studies, as I recall, handle age pretty well. And what I was slightly concerned about is that there was a conflating here between confounding by age versus sometimes a stronger effect is seen at older ages. And that would be a different thing and not something that would detract from the strength of the paper. It would be just more like in older people, we tend to see a stronger result. So I just wanted to make sure that wasn't based on this idea that maybe there's this sort of effect modification by age, which would not, again, importantly, would not detract from the strength of the study. It would just sort of say, it seems to be more of an issue in older people. Because I do think most of those studies probably relatively reasonably handled age, but and let's see, where was that the end? Yeah, I think that's all.
Thank you, Susan.
Yeah, just a housekeeping issue in that IS1 table, summary table, in addition to the causation category for mortality being incorrect, the one for neurodegenerative diseases is listed as likely causal, but I think the ultimate determination was suggestive. And I just want to reiterate what Chris said about internalizing disorders. This did come up yesterday, and it was my impression from the literature summary that was provided in the health appendices that that was more strongly likely to be causal than likely causal, and that impression is repeated in the integrated summary as well. So, I mean, we can add it in our comments whether we think the causation determination for that outcome may need to be rethought. But Chris, I agree with you, and that's what we talked about yesterday. And I guess to build on Mark's comment, I think the confounding by age was an issue with bone-led studies, right? And a lot of those studies do adjust for age pretty well. But I think there were a couple of instances where there were issues of confounding concerns related to psychopathology in adults. And I think the age relationship with psychopathology is much less clear, for example, than the age relationship with blood pressure. So even if it were a confounder, which it's unlikely to be in studies that did a good job of adjusting for it, for those particular outcomes. I think it's unlikely to be because it's not, the relationship is not so clear cut. And I guess the last thing there's another section where I read it a number of times and still I'm not sure I understand it. On IS 101, there's a discussion about, and this comes up in the appendices as well, that studies that look at later childhood exposures independent of prenatal exposure. So for example, adjusting for prenatal exposures are not really relevant. And I was having a hard time with the key exposure period being early life or prenatal, having a hard time understanding why they weren't relevant. And it seemed like part of the implication was they weren't relevant because older children are likely to have had exposures in earlier life that can't be well characterized and that may not be representative of current children. But if you're adjusting for those early life exposures, then in theory, you've addressed that issue, at least in part. And it seems to me understanding the role of lead exposures across the life course, including both early and later childhood, is very relevant to understanding the health risks of lead. So I guess to say it's not relevant, I think needs to be qualified in a way, because relevant to what? Relevant to understanding prenatal exposure or relevant to understanding lead effects? And I think overstating the problems invoked by populations that have had higher past exposures, I think that can be overemphasized sometimes in both the IS and the appendices, and discounts a lot of literature that's very informative. And sort of in response to George, your question about, how well does this integrated summary reflect the health appendices? And I think it generally does a really good job. With that said, I think some of the general limitations of the health appendices that we talked about yesterday also apply here, because some of the same summary language was used, and some of that language might be clearer if it were edited a bit and refined a bit. And so those same general issues that were present in the appendices are also present here.
Thank you, Brissa. And then Jim.
I want to echo what Susan just said about the challenges of basically disentangling the timing of exposure. And that, although it is challenging to disentangle the timing of exposure and be able to just say, it's right here, this time window, that's hard to do. The fact that we can't necessarily do that very well doesn't detract from lead as a causal lead exposure. So I just want to really emphasize that there are passages of the text where it may lead the reader to conclude that, well, we don't really know when, so therefore, do we even know if lead has an effect? I mean, so I think maybe adding a clarifying sentence here or there to say, despite not being able to attribute a specific window, it's still right.
Thank you. Go ahead, Jim.
Yeah, I had a comment similar to the comments I made yesterday about some of the graphics. So at the beginning, there is a map showing the lead in the soils, but there's no map showing any ambient air quality or the location of the monitors. And I know that that's in the appendix, but I think it's important to at least have one graphic showing the location of the ambient monitors and the current concentrations that are being read by those ambient monitors. Also, there's no mention of non-attainment areas, and at a minimum, I think at least a list of the current non-attainment areas should be added to the document.
Thank you. Other discussions on the integrated summary? You have enough, George? Oh, Phil.
I have just one maybe follow on comment on the very first box of this section, which again is on, well, it's on page 38 of the PDF. the integrated synthesis for lead has the two topic headers, human health effects and then welfare effects. And one of the themes that we've struggled with a little bit, I think, is, and this goes, Chris, you brought it up again with the presentation of the conceptual site model and trying to understand the contributions of the different sources of lead to air concentrations and therefore the relationships between air levels and blood levels. In the welfare effects section, it actually begins with a little bit of a discussion of exposure uncertainty. And I'm just going to read here a little bit. It says the effects of lead in ecosystems are primarily associated with lead from deposition and other sources, which begs the question. I mean, it probably is suggesting that there's direct inputs into waterways and things like that, but it's an important uncertainty. And at the end of that paragraph, it says, however, the relative contribution of lead from different sources is usually not known. And so here we have in the welfare section, it captures it well. It's an important uncertainty. There's no equivalent sort of acknowledgement of that challenge on the human health side. And one suggestion I have is that maybe those titles be expanded from human health effects to human health exposure and effects, and the same for welfare to welfare exposure and effects. And that then provides an opportunity to expand upon, maybe with more than a phrase in one bullet, but maybe one or two separate bullets that really capture this difficulty in making the compartment relationships between the relationship between what's in air and how it got there, both on the human health side and on the ecological side. So again, just to be a little more pithy, my recommendation is change the titles to include exposure, both on the human health and on the welfare, and bring in a little bit more of the synthesis of what's known and maybe what the key uncertainty is on the exposure piece. Thanks.
Thank you. Jim, you're left over, right? Okay, I don't see anybody else who wants to speak. George, do you have what you need, you think, to summarize things?
I do. I think it would help since, this section just covers a huge amount of territory. If panel members have comments that are not in their individual comments and they think are points that need to go into the consensus portion of our report, to send me a snippet of text that really highlights the part you want carried forward, because maybe there was just a wide-ranging discussion and I can try to pick it out, but it would help if you have pieces that you want brought forward to do that. And of course, also if there are really important points that you want as candidates to go into the letter part of it, the highest level summary, then make a note of those as well. But other than that, I'll try to put it together as best I can and get it around.
All right, thank you. And so let's have a status report. We've blown past the scheduled break, but we can take one in a few minutes. I guess before we do that, is there anything the EPA wants to ask or follow up with this discussion?
This has been actually an incredibly helpful discussion this morning on the ES and IS. I think, as you know, distilling down 2,000 pages into 100 or even shorter than that is very challenging. So I think it's been really helpful to hear what this panel feels are the most important aspects of the ISA that we want to bring forward. So we, took careful notes on that today, and also look forward to seeing that specifically if you have specific recommendations on what we could bring forward and how we can make that more clear in what we're communicating in these front two sections of the ISA. So really appreciate the conversations. And then I think with some of the discussions that the panel has had about causality, obviously, clear communication about what your opinions are, where there may be differences in how we the conclusions that we came to, those would be very important. So,
Yeah, and that was what I wanted to follow up on now, because we mentioned this yesterday. There were a couple of areas that we might not have drawn the same conclusion that EPA did. And Susan, I might want to put you on the spot because you said you put a list together of those. And so, yeah, so I'll give you a second. And so we're pretty much at the end of our discussion of the ISA. And I propose that we try to wrap it up and then take a break as opposed to having, and then we'll have a good transition to the IRP. And so as far as I can tell, this is the main remaining topic that we should discuss. It's not really on the agenda, but we should come back to this topic about the causality conclusions. And it's worth, while we're all together, able to deliberate to at least air those and see if any further discussion is needed. And then, of course, the small subgroups are welcome to develop their thinking more in a more refined way. And we will have an opportunity in public at our follow-up Zoom meeting to air any of that if our thinking evolves in ways that we haven't gotten to today. So I don't want us to feel like we, have to have the final answer today. We can continue to reflect on these topics. But it was helpful to hear from Susan last night that she'd put together a draft of the ones that she had questions about, and then we can all go through those together. So are you ready to do that?
So this is actually, I tried to synthesize everyone's comments on this. So the first outcome where there was discussion of a potential different causality determination was adult cognitive effects. And I think Brian suggested that it should be causal as opposed to likely causal. Is that right? And so that was, should I just go through the list and then we can iterate back? I had raised a question about whether the renal should be causal as it was classified versus likely causal, but I think the consensus from Bruce and Brian and others was that it should be causal. So maybe we can just put that one to rest. The birth outcome, which is a concatenation of a lot of different measures, right? And you didn't necessarily provide a causal determination for each of the measures contributing to birth outcomes. So I'm not exactly sure how this would play, but Bruce made a couple of comments about areas of birth outcomes that he thought were causal, including preterm birth and preeclampsia. Whereas the overall birth outcome category was categorized as suggestive causal. I don't know how you integrate, we've talked about this yesterday, how you integrate the different components of birth outcomes and coming up with a summary causal determination. But, and because there weren't causal determinations for those individual pieces, I don't know how much of an impact this will have. And then I had, within the birth outcomes category, I had also felt that that the pregnancy loss and pregnancy and fetal loss should potentially be likely causal or even causal versus suggestive. And then I had mentioned yesterday the description of internalizing behaviors, which Chris also noted as sounding like something that would be considered causal, whereas it was categorized as likely causal. And then the last thing I also mentioned was my thoughts that female reproductive function, particularly the data on age at menopause, seem to be likely causal as opposed to suggestive. And that I know there are a number of factors that go into the female reproductive function measure, but analogous to the male reproductive function, where there are a number of factors and the causality determination, to my mind, seem to be dominated by semen quality. I think it's not inappropriate for female reproductive function to be dominated by menopause, given the long-term and important health consequences of early menopause. So that was my list. And then obviously, if I've forgotten something, others should chime in. Does that?
Yeah, thank you. I think that's really helpful. And are there any of those that people want to discuss? Yeah, Perry.
Well, or just I would add to your list, we talked about cancer because in one place it says cancer and mortality, and another it said cancer. So I think we had some questions about how that was determined.
Yeah, I think, and maybe I misunderstood this, Brian, but the final summary statement around causality for cancer said it was based on cancer incidence and mortality, when in fact it was based on tox studies, right? So that was what we wanted to have corrected. It wasn't so much the causality determination, but the evidence that was driving it. Am I understanding that correctly? Yeah. So I think we were in uniform agreement that it's.
Yeah. But also just the wording, because in one place it was cancer and mortality. And then in the summary table, it was just cancer. So
Okay.
just to
Yeah.
clarify that issue. And the other one was about separating out mortality and making a determination on mortality rather than breaking it down into all cause and cardiovascular.
Thank you.
But again, I don't think there was difference of opinion about causation, right? We pretty much in agreement that the relationship of lead to mortality, whether it's all cause or cardiovascular, is causal, right?
Yeah, I think that you're making important points about how things are presented, but I think we're also trying to sort out whether we agree with the causal conclusions. And so your point is that it's not that we disagreed with the conclusion. It was more about the presentation. Yeah, Chris.
I had questioned the determination for neurobehavioral effects on aquatic invertebrates.
To remind us, please. What are you recommending instead of what it was?
Well, that at least based on my reading of the document, that it seemed to be it seemed to be worthy of a causal determination, but it was one level below that.
Thank you.
And there was a little bit of give and take on that yesterday.
Thank you. So so it sounds like maybe renal, we don't need to revisit. That's what, but and do we need a little bit further discussion? Because one of the things it sounds like we could do with the birth outcomes is recommend that they not be all lumped together, given the discussion we had yesterday. So that would be a way of addressing your question about how do we deal with the fact that some look more causal than others. Go ahead.
Yeah, and I think that's a really nice approach, because I think the sort of pathophysiology of a lot of these birth outcomes is quite different. So prematurity is very different than birth weight. I mean, and so it's not necessarily the case that you would expect lead to be homogeneously impactful for across all those different physiologic processes. And because each one of them is, again, this is my sort of public health value, is really important in terms of both child health, but long-term health and maternal health. Separating them out, I think, seems not unreasonable.
Okay. And any other further discussion on this topic? Thank you for providing that summary. That was really helpful. Okay. Are we done with the ISA then? Anybody else have anything else? So summary and action items is about the ISA. I think most of us are familiar with the process where the lead discussant will create text based on our discussion and our written comments, and then circulate it to the people who are listed on the agenda, as well as anybody else who chimed in or expresses interest in joining the groups, as long as it's less than half of us. And Erin will provide us with deadlines after the meeting. And then You're welcome to recommend text for the letter, but often we do that. Aaron and I do that after we get the draft consensus comments. So either way, if you want to recommend it, that's fine, but we can also try to do that based on your consensus comments, pull out the most important points. So that's I think that's what's it for the ISA. So the other thing is we should take a 15-minute break, and then we're going to switch to the integrated review plan. And given that we're ahead of schedule, we had the whole afternoon scheduled for the IRP. Whether we will take the full 4 hours or not, I don't know. So I think Aaron had the lunch orders held by the contractor. So a question is whether we, after the break, we just go through the whole integrated review plan without a lunch break, or take a lunch break and then finish whatever we haven't finished. So what's your pleasure, Chris?
Is that a committee of the whole discussion? There were no discussants that were.
Yeah, so it's just, and it's officially a consultation, right? Do you want, yeah. Aaron will
Yeah,
clarify.
so just to clarify, a consultation is not a consensus response report. So typically the end result of a consultation is Leanne will send a pro forma letter to the administrator indicating that this consultation took place, and then all your individual comments will be appended to that. So it's just individual comments, but it can be informed by the discussion today.
So should we take a vote? Any strong opinions? People have to leave early. Go ahead, Brian. You want to?
It's hard to opine on this without knowing how much time we will, I mean, if we're not going to eat lunch until 4 o'clock, that would be a problem.
Yeah, I would agree with that. Well.
I vote we
Gary.
keep lunch on schedule because I have a meeting.
Okay, well, anybody object, we'll stick with our schedule, and we'll just start the IRP after the break, and then we'll take the lunch break, and then we'll finish when we finish. Okay.
Okay, and then
Thank
if
you.
you haven't done your lunch orders and you want to, please fill those out, and you can hand those to me right now.
All right, so 15-minute break. So that means we'll be back around 25 of, no, excuse me, 20 of. All right, timer has told us our 15 minutes are over. People want to get back to their seats and get ready to get working. So an update, we're going to extend our break by an extra 5-ish minutes because some of the key EPA staff who would like to be here from the beginning were at another meeting in North Carolina, not in Washington. So they'll be here in hopefully about 5 minutes. So get a little bit longer break. So after consultation with EPA, we'll go ahead and get started without some of the people we're waiting for. So if people want to take their seats, we'll get started. So I think, so we're now starting on our review of the integrated review plan, volume 3. And I'll turn it over to EPA to introduce themselves and to give us their presentation. And also, well, maybe you were talking about wanting to split it up and have discussion after each section, so we can do that.
Great, thank you. My name is Deirdre Murphy with Office of Air Quality Planning and Standards. And if we could switch to the next slide, I think we have some cast of characters. Many of these you've met from yesterday from ORD. With me here is Dr. Zach Picard, who is the lead on the health and risk assessment. He and I actually have been on lead NACS reviews. This is our third one. We started with the 2008 review when there was quite an elaborate risk assessment performed. And then the person who is helping on the secondary, Lee Meyer, is out on maternity leave. So I'll be picking up the welfare slides for this section. But as Dr. Shepard mentioned, we'll divide the presentation. We'll go through a couple of intro slides, and then Zach will talk about planning considerations with regard to the human exposure and health risk assessment. And then we'll go ahead and you all can have deliberation and consult. We'll take your consultation on the planning considerations and initial plans for that. And then we can do a couple of slides for welfare and talk about that if that works for everybody. So if we go to the next slide, this just shows the outline, a couple of slides of background, and then the health risk, and then welfare risk is the idea for the presentation. And this slide is just to remind you all, I think we included this slide back last year when we had a briefing on Zoom for volumes 1 and 2 of the integrated review plan. If you'll recall, volume 1 is the background document that's available. It's on our website. The link, I think, was provided with the charge questions. It provides information about the last review, about monitoring regulations, et cetera. Volume 2 was the planning document particular to policy relevant questions for the entire review, and then specifically areas and planning for the integrated science assessment. And as you know, now we have the draft of the integrated science assessment that you all have been discussing. And so we're straddling the first 2 boxes of this diagram. We still have the third piece of the planning, which is the planning for quantitative exposure risk analyses. And that's what we're here to talk about now, while the ISA is moving forward in the assessment part. Once we do our quantitative assessments, we'll be moving into the policy assessment piece, which is where those assessments are reflected. And then after, and we depend very much on CASAC advice and deliberations in those parts of the review. And then once we complete those assessments, we move into the rulemaking part where we, in the agency, we have processes for proposed and final decision making. So then I just have one more background to kind of ground folks in where we are with regard to lead. The current standards for lead are 0.15 micrograms per meter cubed, and that's in terms of a three-month average of total lead in total suspended particles. The last review was completed in 2016, and that retained these standards, which were established in 2008. Now, in the 2008 review, first, the primary standard was substantially revised, including a lowering of the level. It had been 1.5 microgram per meter cubed. That was set in 1978. That 2008 review updated the literature and made a substantial change to the level of the standard, as well as to aspects of the averaging time and form. And that was predominantly based on the evidence for neurological effects in young children, as well as the array of other effects to at-risk populations. In the decision-making, that was informed by an evidence-based framework that utilized air to blood relationships and blood to IQ concentration response relationships that informed the administrator's decision-making, particularly on level. The risk and exposure assessment was considered generally consistent and supportive of that evidence-based framework, and so provided additional support to the decision-making. With regard to the secondary standard, that was also revised from 1.5 down to 0.15. So it is now the same as the primary standard because the data, the evidence were not sufficient to provide a separate foundation for that standard. However, the decision was made by the administrator that the level of the standard needed to be revised downward in order to provide the requisite protection of public welfare. And that was intended to protect against adverse environmental effects, including in terrestrial and sediment dwelling organisms. The last thing I'll mention with regard to the 2008 review, which we touched on yesterday morning, is there were a number of additional requirements added to the monitoring regulations, such that they substantially strengthened to ensure that we had monitors placed near sources with the potential to contribute to exceedances of the standard, which is the purposes of the NACS surveillance network. So with that backdrop, I think I'll turn it over to Dr. Picard to talk about the key planning considerations with regard to the human exposure and health risk assessment.
Can everybody hear me? It's clearly okay. So, you know, the 2007, let me just start with a little bit of sort of flow and the way I think we're going to do this. We thought it would be useful to go and present a little bit of background on the 2007 risk and exposure analysis, the REA, just to sort of set the stage for what was done. And then from there, we'll talk about the new evidence, how that informs addressing uncertainties, possibly updating the model, and then rolling into the plan for that's proposed in the IRP for the current risk assessment, REA. I think those of you who have been part of this since 2007 realize that this is a really complicated analysis. The 2007 analysis was very complex. And although I think in some ways this has some simplicity, this is going to be most likely a complicated analysis too. And what that means is in trying to provide an overview, I could be up here if I really got into the details for 2 hours. And I don't really want to do that all. I like talking about this stuff. But that means that I'm going to probably do essentially what's a 20,000 foot flyover. I'm going to be moving through some of these details hopefully quickly. But if folks have questions, obviously, if you want clarification on points that are made, we're more than happy to clarify. Yeah, did you?
Might hold that to the end just to keep it.
Yeah. So if and I guess a good point. If you want to hold your questions until the end, I'll try to move through things, and then you guys, then you folks can ask any questions that you might have. So we wanted to begin by giving an overview of the pathway nature, the multi-pathway nature of a lead risk analysis REA. And this diagram really illustrates that point. What this is showing is the various pathways that are associated with ambient air sourced lead. And if you begin on the left-hand side, you'll see obviously when we're talking about ambient air, we're talking about inhalation. So obviously there's an inhalation pathway. Moving sort of towards the center a little bit, one of the most important pathways in an REA focusing on lead is indoor dust, even when you're looking at ambient air. So ambient air is exchanged with indoor air, so outdoor air to indoor air within residential spaces and other sort of occupational spaces. And then that loads indoor dust lead surfaces, and that ends up being a very critical pathway that drives exposure and risk from an ambient air standpoint. In addition to that, you have a number of other pathways that are illustrated here that can be conceptually and technically linked to ambient air. That includes obviously outdoor soil and dust, dietary items, and drinking water. I think an important point, the reason we need to consider all of these pathways is, as most folks I think are aware, there are a lot of nonlinearities when you're modeling exposure to lead and concentration response functions when you're specifying CR functions. When you have nonlinearities in exposure and risk modeling, what that means is that you really have to consider the total exposure to know where the child or the adult or whoever you're modeling is on a concentration response function. And so you can't simply look at a pathway or a subset of pathways that are of primary interest. You have to consider total exposure. And so that's illustrated here. Just to, very quickly, the green circles are showing that there are other sources, obviously, of lead besides sort of de novo ambient loading or even entrained ambient loading of ambient air. We're talking about lead paint, obviously other sources. I think the other point I'd like to make on this slide is that in 2007, in that REA, and also most likely in the current REA, if you imagine sort of a policy-related dial, if we look at lower ambient standard levels,
We actually could show those changes in terms of changes in inhalation, obviously, and also that residential indoor dust-led pathway. Those are the two primary pathways that sort of were in our modeling provided with dials. So as you considered alternate standard levels, you would see differences in inhalation and indoor dust ingestion for children. Clearly, the other pathways could be affected by changes in ambient air, but either they have a longer profile for that, and or technical complexities meant that for those other pathways, we typically would use nationally representative or other types of representative background concentrations, and they would be fixed. So that's just a little bit of hopefully a setup. Next. So this is a small screen. Wow. Yeah, thank you. I think I'll probably try looking at that. So in the 2007 REA, just to give a couple of slides as background on that slide, on that REA, the last REA that we did, we conducted a multi-pathway probabilistic population-based analysis focusing on younger children 0 to 7 years of age, and we focused on IQ loss. And folks probably remember that from if you have looked back at some of the information. That analysis was a case study-based analysis, and we had several categories of case studies, with each category allowing us to look at certain questions that would be sort of important from a policy standpoint. We were interested in what kind of exposure and risk children would have when they were at the standard level. And in order to do that, we included what we called a generalized local case study. And that's essentially, imagine a group of kids in a small neighborhood experiencing the standard level of interest. We also modeled Herculaneum, the primary lead smelting facility at that point, and the smaller ring closer to that facility essentially had ambient air level at the then current standard, fairly elevated levels. So we could look at risks there to get a picture of what kids were experiencing at the standard, the then standard. Obviously, we're also interested in a broader picture of exposure for children in an urban setting. So not just kids at the standard level, but what might you see in a more representative, broader urban context. And so we included a set of case studies called local urban case studies, and those looked at specific cities in modeling population demographics for children within those broader urban areas, LA, and several other cities that we looked at. I think the takeaway from those broader urban study areas is they're interesting in providing a representative picture of broad risk, but that risk picture gets diluted by a lot of children at very, very low exposures. And so when you look at mean risk, or you look at 95th percentile risk, you have a distribution that's heavily weighted by very, very more lowly exposed kids. And so ultimately, we ended up placing a lot of emphasis on that generalized local case study, is really allowing us to ask clear questions about public health protection for the standard level. So moving on to the next slide. So this illustrates these three sort of types of case studies. I'm not going to spend a lot of time on this, but on the left-hand side, you see the generalized local case study. That's assuming a group of kids right at that standard level, uniform air concentrations for whatever standard you're looking at. And then the Herculaneum facility is represented in the middle. And then one of the sort of city-specific analyses is represented on the right. This illustrates the fact that we did block and block group level simulation of kids within those sort of more differentiated areas on the right, modeling in detail exposures within each block or block group, and then aggregating that together to get an overall distribution of risk. Anyway, moving on to the next one, I want to make sure I'm not getting bogged down too much here. Yeah, thank you. So this slide presents a little bit of information on the way media concentrations were characterized in the different case studies. From an ambient air lead standard, ambient air perspective, for cities, we had monitoring data, and we had interpolated surfaces between the monitoring data. The generalized urban case study, obviously, we simply set the level at the standard we were interested in, so there's no real modeling. And then the Herculaneum, there's a bunch of fairly sophisticated dispersion modeling that was done for that facility. Now we get to indoor dust. As I mentioned before, indoor residential dust is a critical pathway. And in 2007, and you're going to hear more about this in a second, we spent a lot of time developing a hybrid, a de novo model at that point, linking ambient air to exchanges with indoor air to deposition to indoor surfaces. This is a compartmental sort of flow model that was pretty sophisticated, performed relatively well when we compared it to empirical data. And that model really was a critical part of that overall risk assessment, this hybrid model. It also included the need to use empirical data to go from dust lead loadings to concentrations, that sort of being an important translation needed to model blood lead. So anyway, that's an important point to note. Outdoor soil, as I mentioned, we did not simulate changes in outdoor soil in 2007 based on changes in ambient air. We used background data from various sources. And I think the final point here is one I've already made, which is the pathways that were really critical in terms of seeing changes in exposure and risk based on changes in ambient air levels were in direct inhalation, which was not a significantly important pathway, ironically. It was the indoor dust pathway that really drove changes linked to different standard levels, that indoor incidental dust ingestion. So moving on. So this slide simply makes the point that, and I guess we probably could have had a nice graphic showing this, but we generated a fairly complicated set of risk estimates that were dimensioned in different ways. That dimensioning of those risk results reflected the fact that we had treated different pathways different ways. Some of those pathways were varied. Some of those pathways, like dietary ingestion, were essentially fixed at background levels. And we provided a range of risk estimates reflecting that spread and the way we approach pathway modeling. Importantly, we also had 3 or 4 different ways of characterizing IQ loss with different CR functions. These are all based on the Lanphier pool analysis. They had different methods for going from essentially for tackling sort of the lower exposure range, which was critically important to this. Anyway, so that was another part of that dimensionality in the way we modeled risk. And then, oh yeah, thank you. Okay, so now we get to next thing is this one. Yeah, great, thanks. So now we get to our thinking about this current risk assessment. And I think there are a number of ways of thinking about the design. And one of the first questions we had is, what did we learn from the last time around, right? And I noted that we had a range of case studies, but in the end, the case study that really had the greatest utility from a policy standpoint was this generalized urban case study. Deidre mentioned a few minutes ago that the evidence-based calculation using direct empirical evidence was sort of the foundation for the changing of the standard, and that was true. And the risk assessment was essentially used as support to show that this evidence calculation had sort of complex mechanistic empirical support. So if we model risk in a complicated way, we get results that are very similar to what this simpler direct evidence-based approach was. That generalized urban case study or generalized local case study was the case study that really allowed us to look at risk, what's being done when using that empirical approach. So a big take-home message is we really think that the generalized local case study has great utility, greater utility than the other case studies moving forward. And you'll see that, and it's reflected obviously in the plan that we laid out. All right, so now a critical question when we ask ourselves, are we going to even do a risk assessment in the first place, is that if we look at uncertainties in the 2007 REA, one of the questions is, do we have new data, new information that is going to result in a significant updating of this model such that we think we might get different exposure and risk results? I mean, that's an important aspect of this. This slide is designed to sort of capture that discussion, which is a big part of the IRP chapter on all of this. The answer is, I think, yes. I think we have some excellent information that really calls for us to obviously redo the risk assessment. And just modeling, moving through those very quickly. The first bullet is again, sorry, can we move to the next one? I jumped ahead. There we go. Sorry. Now we're on the right one. So the first question is, do we have reason to believe that we could update this hybrid indoor dust lead model, this complicated model we developed? And I think we definitely have new information. We have better information on going from loading to concentrations. We have updated information on the air exchange rates and a number of other factors related to that model. And we've actually already working with ICF, done a lot of progress, made a lot of progress in updating that model. We're not ready yet to show that, model results here, but I think we're making good progress, and I think that model will probably perform differently. So I think that's a good finding. Very quickly, the background concentrations of dietary drinking water, that's obviously going to change. Dietary background concentrations in those media in 2002, 2003 are obviously different than now. So if we're thinking about, dietary sort of background concentrations, those are going to be updated. The characterization of blood lead levels using empirically derived GSDs. So this is one of those rabbit holes that I could spend a bit of time here. And I don't know that we want to take that time unless folks want to talk about it later. But rather than probabilistically simulating lead intake for individual children within a city, we modeled it within a block. We modeled a single child with pathway apportionment, doing that in a really rigorous way. And then we used a statistically derived GSD based on sort of neighborhoods and other sort of spatial dimensions of demographics to establish a distribution of blood leads around that mean value. So that allowed us to, there are a bunch of reasons for this. We could talk a lot more about this. Interest people may want to have questions about that when I'm done. But the bottom line is, if we use that GSD again, that GSD approach again to derive a distribution around a centrally modeled child to get a range of child values around that, that GSD is based on demographics. It can be based on NHANES. It can be based on smaller neighborhood studies. And we would probably base it on a number of those things to provide different characterizations of variability. And that would probably change from what we would have seen in 2002, 2003, 2004. And then finally, in terms of the IQ loss modeling in children, looking at that IQ point and that IQ endpoint in particular, we think there's reason to believe that rather than using, if we're going to go back and look at studies that characterized IQ loss in more lowly, that's the wrong term for that, kids are experiencing lower levels of exposure. One option would be to focus on the Boston and Rochester cohorts from back then, because those actually provided kids that had relatively low exposures in sort of that 2 to 5 microgram per deciliter, 2 to 7 microgram per deciliter range, which is likely to be where our analysis is really asking to characterize risk or needing to characterize risk. All right, so next slide. So I think this is obviously a point, I think, of interest for our discussion here, I would imagine. The other question is looking now to new information and new data. What do we think when it comes to consideration of additional endpoints, populations, and life stages? And I'll go ahead and I'll sort of give away the punchline in the beginning here. I think, one thing that's really important to consider is we have a fairly high bar for the confidence with which we model risk. And in our estimation at this point, when you consider the need to link indoor dust lead to the population that's most critically driven by indoor dust lead, that's likely the young children. When we're talking about needing to model blood lead values as the biometric, we're going to have the greatest confidence in doing that for children 0 to 7 years of age. That cohort, the use of IUBK in that context has been well vetted. You have the Bunker Hill studies that have shown performance within the range we're interested in. And then finally, we obviously look at endpoints and we think, IQ loss, notwithstanding some of the concerns raised earlier about demographic issues and SES and, disenfranchised populations. I totally appreciate all of that, but IQ still continues to be an endpoint of clear public health significance, given some of its concerns, and I understand that. It also has great precedent for being used, and there's a lot of literature on that particular endpoint. So for that reason, before I get into our other points, I think we are really focusing again on IQ loss in children 0 to 7 years of age. In considering some of the other factors, clearly there's causative support for a number of different endpoints, and we've had great discussions here. But the point I would make is just because we have very strong causal support for something does not mean that when we look at which metric is clearly associated with an endpoint, our ability to predict blood leads for that demographic population with high confidence, we can do all of these things, but what is our level of confidence going to be? And the only point I would make is relative to IQ loss in children, I think our confidence is going to be significantly lower in making these other estimates for reasons we can talk about. And so particularly if we look at additional neurodevelopments in children, ADHD, obviously we've talked about school performance effects, and these are well characterized. I think a lot of support for those endpoints. There are concerns about those when you try to put together the modeling chain to do these estimates. So one thing would be, in a number of those cases, not always, you're going to be modeling older children above the 7-year cutoff for IUBK, which means you're going to be using all ages lead model, most likely to simulate those children. You have more complex patterns of exposures that can be associated with the endpoint. And so you're going to have lower confidence. Again, it's not that you can't do it, but you're going to have reduced confidence. And then if we move to endpoints in adults, there's a broad discussion about this, obviously. I think the ISA makes the point that even though there's a very strong causal association, there still remains some uncertainty about the timing, the duration, and magnitude of exposure that's associated with those cardiovascular changes. And I think that's an important thing. We have to specify a metric for modeling mortality. let's say. And what is that metric going to be? Or do we even have access to some of the metrics that might be in play? Lifetime average exposure versus more of what I would call a concurrent metric. That's what a more current NHANES value might be. So some of our concerns. I think the other thing that's in play here, I'm going to sound a little defensive about this. We don't have a lot of time to get this analysis done. The timetable is very tight. And so part of what we're trying to do is make sure we can generate a high confidence risk estimate that will have a lot of utility to management that we can present. And so that's the reason for the proposed focus on IQ. Lost into saying it's obviously proposed focus. All right. So with that, moving on to just two more slides, it'll go hopefully very quickly here. So this slide lays out the approach that's proposed in the IRP for the REA. I've basically now identified all of these points, so I think I can move through these very quickly. We're suggesting a case study approach that focuses on this generalized local case study. Obviously, that's a very simple case study to apply. You're not doing demographic weighting. You're not selecting a city. And it's not that for following analyses, we wouldn't necessarily consider doing a more complex representational analysis like an urban study area. But in the interest of providing sort of high utility information, we're proposing to focus on that. With regards to health endpoints, we're proposing obviously to focus on IQ loss in children 0 to 7 years of age, but we could, and we mentioned here, depending on other considerations, consider other endpoints as endpoints possibly simulated with lower confidence or sensitivity analyses or some other construct. Exposure modeling, I think I've already covered that. It would be IUBK based. I mean, we could use all ages lead model for that 0 to 7 year range. I think there's been analyses that ORD has done that shows that the models perform very similarly. And then finally, uncertainty characterization. Well, sorry, CR functions for IQ loss. I already mentioned this. Both Bellinger and Canfield provided concentration response functions for their sort of more the kids exposed in that under 10, under 7 micrograms per deciliter range, which provides a really nice CR function. One obviously is for a more advantaged population. One is for a more disadvantaged population. I think there's utility in that. They're both very strong functional forms. So we would propose using those two. And then the final point I was just going to make is I think characterization of uncertainty, and this is getting back to a theme I mentioned earlier. If you think about exposure analysis as sort of hooking together analytical elements, you have a dust lead model, you have a blood lead modeling element, you have CR functions. One question is the performance space of each one of those elements. At what point are we asking our dust lead model to perform outside of its parameterized range? It's not that you don't do that. It's not that you don't think you're generating reasonable estimates, but I think it's valuable to be able to identify when that occurs. Similarly for IUBK, it's been performance evaluated using Bunker Hill data, which allows a target blood lead level of 5 micrograms per deciliters in 95th percentile. So that's sort of the performance range. Are we asking it to perform at the lower end, most likely a little bit below that? What does that mean? And then obviously with the CR functions, we might ask a similar question. I've always thought that, and I think we feel that that's an interesting perspective to take on uncertainty and confidence characterization. Again, not that we would not do those calculations, but we would want to identify when we're in a range of extrapolation beyond model fit. So anyway, the final slide. I'm not going to go through this. This did take a while to create a while back, but this basically is a graphical illustration of what I just presented verbally. It's our plan in more of an sort of an analysis space. And if we have questions about what we're doing, we may want to leave this slide up. That may be informative. The orange boxes identify where the new information, the really new information are, and therefore where we are likely to be updating the overall model in critical ways. And so I think that's obviously in the IRP. So anyway, thanks for the time.
So I think now the plan is to open it up for questions and comments from the panel. Phil.
That was really helpful. Thank you. It led to 2 or 3 questions. I'll try to be succinct and quick here. It helped frame for me, again, the connection that you're really trying to make between the standard and exposure, which, given the modeling constructs that you're using, I think about it as average daily intake, micrograms per day. And then the question is, and your focus on the indoor air model component, how do you get from outdoor air concentrations, ambient concentrations into the indoor environment? leads to two questions. One is at the point that the model, the indoor dust model, generates an estimate of what contributes to the dust reservoir. Is it true that at that point it's mostly thought of as dominated by an ingestion pathway? Okay, so you're not bringing any particle size distributions or any, it's basically trying to get from mass loading to concentration in air and then picking up IUBK's use of that as an intake.
Yeah, so you go from a standard level to an equivalent annual average. That's what we would do first. And then that annual average is used. The dust sled model, essentially, it's a compartmental model. It's a flow model that's been solved for steady state, and it includes penetration efficiencies. The issue of particle size, and this is something that we're still working through, but the issue of particle size, deposition velocity, I want to say, I think penetrance indoors, I think is affected by that also, is a complicated factor that we've been trying to work through. I think we made really good progress on that. That'll be an important part of this and part of the uncertainty, but essentially, once you have this loading as a flow, you also have outflows and cleaning frequency and efficiency. That's been part of where, is it carpeted? Is it floored? What's our ratio split? We actually considered very quickly doing regionally differentiated models of indoor housing for this. We're going to go for a more generalized housing approach, but then have sensitivities that look at the sensitivity of this model. So yes, you get it to sort of hopefully answer your question a little more directly. You go from a standard level that is not as an annual average to an annual average value that is then used as sort of a more ubiquitous concentration that loads indoor dust. Saying this, I could see that there could be uncertainty because you could have indoor dust respond more quickly to a level closer to the annual standard, get a higher dust loading relative to the equivalent annual average. That's maybe something we should think about a little more. But yeah, and then it's incidental dust ingestion by children.
Yeah, that was really helpful. All right. The common thinking about childhood hand-to-mouth activity now is that it's all dust. Some of it is during outdoor play, some of it's indoor dust. And if you look closely at the way the literature at least seems to support that partitioning of total average daily soil and dust ingestion, it's maybe about a 50-50 split. So indoor dust maybe contributes, the activity patterns occurring indoors maybe are 50. Question is, how or are you, and that flow diagram was really helpful. I saw outdoor soil as sort of a separate compartment. When I think about the work that Van Linder and others did at Bunker Hill to try to improve upon estimates of soil and dust ingestion rate, what resonates with me is the effort to examine outdoor soil in different spatial scales. And there was I'm sure you're familiar with this, detailed sensitivity analysis to try to understand what seemed to give the best correspondence between model predicted estimates of exposure and blood leads and observed in the Bunker Hill community. How is outdoor soil, the air deposition component of outdoor soil accounted for? Is it now part of the background, and then you're really focusing on the additional dust component, or is there still a connection between, you change that dial in the air standard and affects both outdoor deposition and indoor dust together? So I'm trying to understand the connection.
So the thing is, clearly outdoor ambient air can have an effect on soil, although I think it's more complicated now because you don't necessarily, I want to be careful, get myself in trouble here, but I think if you go back to gasoline time when you had a de novo source, it was constantly being loaded in ambient air into soil that was sort of, I'm not saying you didn't have entrainment, but now I think it's a more complicated pathway. You may have certain sources that are new air sources, secondary smelters or whatever, but you probably have a lot of entrainment coming from obviously urban dust. You have demolition of leaded buildings and other things that are loading air. So clearly there's a relationship between ambient air levels and soil. I think that relationship is complex. It's complicated to model, and we sort of punted. And so we ended up using a default value that we include as something we in the past, and probably this time we'd also call, we had recent air lead and we had past air lead, and the outdoor soil was put in past air lead but there was a weakness in policy space because we were not adjusting that. So DJ, you want to add anything or is that?
Yeah. No, I think that's a good intro too. There's sort of two places I would say that get at what you're talking about. And Zach touched on them and I'll just maybe magnify. So the first is that it's not just air loading to soil, but as we know, the evidence in the ISA very clearly makes clear you have resuspension of lead that had been deposited. And so when we take an air concentration, we recognize that that air concentration has contributions from soil. So there's one way in which soil may be contributing to that indoor dust through the air pathway. The second way, which Zach is alluding to, is you can have exposure to the soil through the kids outside, hand to mouth with soil, tracking it in, all the different pathways folks have done research on. And in terms of what the concentration in the soil is, that was a constant for us last time and will probably have to be this time as well. And to just recognize that that has a component, which is air contribution, we called that the past. And so in reporting out the risk estimates, we had categories because we broke up the total exposure into categories. We had the exposure from recent air, we called it, which was inhalation and indoor dust. And we had recent plus past, which added on some of these pathways that we had to identify a constant concentration for that media, but we knew there was a contribution from air. We could not quantify it. We had huge uncertainty in what the air contribution might be, but that would be the upper bound that would encompass air in all those pathways. And so we said that somewhere in between those two was probably what the estimate for the air related risk was. And that's how we played that out. And then we additionally had other sources, which were diet, that kind of thing. The other thing I'll just mention at this point in terms of the recent plus past, in addition to soil, there was a component to the indoor dust that we had that was passed, which may have been had a little lead paint. We don't know. It was an uncertainty area. So when you did that recent plus past, you recognized it was probably more than just air. So if that helps to explain.
Yeah, that's very well explained answer to a complicated model, basically, about how outdoor soil and indoor dust can combine. Last question I had, and this was prompted, Zach, by your kind of helping us understand that the idea now is to focus on the case study approach and understanding that you're going to overlay you're going to accomplish variability in blood leads again by overlaying the geometric standard deviation. In the sensitivity analysis or the uncertainty analysis, is that going to focus on the average daily intake? The exposure component is not a fixed estimate, but could vary from here to here depending on different components of the model and the different assumptions. And so that central tendency is actually a range. And is that the idea right now? The thinking behind the uncertainty analysis is to try to understand the relative contributions to that midpoint that you then apply a geometric standard deviation.
So are you talking about the background concentrations like dietary and water?
Just in general, trying to think ahead a little bit to there are going to be many sources of uncertainty.
Sure.
You described well, the strategy still is to use the geometric standard deviation as sort of this proxy to of all the sources of inter-individual variability and whatnot. But it just strikes me that there's in the case study probably good opportunity to quantitatively express the bounds around the central tendency estimate and the contributions, Deirdre, for example, of what you were saying, that just the outdoor soil component has a number of decision points. So is that the thinking right now, that there's going to be an analysis around what that central tendency is?
One of the complicated dynamics of a risk assessment like this is when you're dealing with a mean central tendency estimate and you do pathway modeling and intake, you have all these sort of average intakes and you can make an estimate of average blood lead. When you start asking questions about like a 95th percentile or 99th percentile, and you have different pathways contributing to that, if you were going to treat each one of those individually using distributions of intake rates, you don't have correlational structures always for those pathways. And particularly if we're looking at indoor dust versus outdoor soil versus dietary versus drinking water. And so the big challenge we have, and the reason we didn't do a probabilistic analysis, is because you can do it. But then when you're asking yourself, we have some IQ loss in blood lead value at the 95th percentile, and we want to figure out what part of that is indoor dust. Well, if you don't have your correlations well, you may be way off in that, or in the non-linearities also become part of that. If you give everybody in the 95th percentile, compounded conservatism becomes unreasonable in terms of the blood lead value. So the way we treated it is using that GSD, and then getting maybe a little more at your question. I think our range of GSDs, the larger the population you take the GSD from, so the wider the GSD, the greater the potential for that GSD to capture high-end behavior in various pathways. Yeah.
Okay, thank you.
So we would do that.
Davin, you're next.
Thanks. It's really nice to see the modeling approach sort of explained in detail, both with the words and the figures. And I was curious that in the ISA, there's a fair amount of discussion of empirical studies of the relationship between ambient air and blood concentrations and slope factors for those changes, how a change in ambient will lead to a change in blood concentration. And so in terms of the details of the modeling that you're doing now, are there other sort of endpoints that one could look at, or sort of areas where risk modeling would be deemed valid to just sort of look at that slope factor relationship and sort of skip all the middle sort of very process detailed modeling steps? If one were not trying to explain the total amount of lead in blood or the total impact, but trying to look at, say, the marginal impacts of a change in ambient air on a particular health endpoint, at what point is it appropriate to just take those ratios and look at that as a perturbation to a health endpoint, rather than sort of doing the complete sort of process-based modeling that you're proposing here?
So part of certainly one thing that's very important, and I think, is the relationship between, or the ratios that we get from our empirical modeling when we put it together. The dust lead model, IUBK, you can ask yourself for various ambient air levels, how do the ratios that we generate in the modeled space compare to the empirical relationships that are seen? And as you get to lower, for instance, lower ambient air levels, do you see greater dust loading? There's some suggestion that might be the case. Dust loading, the concentrations become their nonlinearities in these various elements of our model that may map and track with some of these empirical base patterns between air and blood lead. And so one of the critical things we did in 2007 was to compare the performance of our modeling approach up to exposure to blood lead, from air to blood lead, to the empirical data, and see whether we had a good fit, or we sort of in a reasonable space or not. That definitely will be something that we do again. And part of the question is, to what extent do we see, lower, if we consider lower levels, do we see these air to blood ratios increasing like you do with some of the empirical data? So I think that was part of it. And then you asked the question, I wasn't sure I was totally following, which is totally on me, is that notion of linking an endpoint to a smaller incremental change. And I wanted to make sure I understood that.
Yeah, I guess there's a fair amount of uncertainty still in these slope factors and around particular levels, but also there's discussion in the ISA of how these are potentially nonlinear and have changed as concentrations in ambient air come down. That being said, as a sort of bounding exercise in thinking about how a particular policy leads to a small perturbation on ambient concentrations, and how that would lead to a small perturbation on a particular health endpoint, just needing to model that perturbation, rather than trying to model where did the entire amount of lead that's in their blood actually come from. Yeah. So just looking at a small perturbation, at what point is it, potentially a valid quantitative approach to directly, draw from those empirically determined slope factors?
I mean, I'll say this, and I think maybe one of the issues is if we end up having nonlinearities in the CR functions, then you need to know where your child, if we're talking about children here, where the child is on that CR function. So obviously, if you believe it's steeper as it gets lower, then you need to know. So asking about that incremental change is something we would do, but we still need to take that, and I may be missing something here, but you need to take that in the context of the total blood lead, to fix them on the CR function, and then ask about that delta space. And that's an interesting thing we tackled last time around is we have exposures from all these different pathways, and an air change Do you put that air change at the very end? And does it get a sliver at a flatter part of the CR function? Are you assuming it to be, and are you pushing it across that shape? So the question you're asking is something we struggled with intensely, and is an important one.
Yeah, and if I can add, because, as we mentioned, we also, the decision back in 2008 to change the standard was informed by this evidence-based framework where we did the simpler approach of considering what are the air-to-blood relationships and what do we know about CR functions. And in identifying the air-blood relationships and then the exposure concentration response, we had to consider what was the range of blood lead that might be of interest because of the nonlinearities, and what were the concentrations that might be of interest. So that was part of thinking about something that seems simple became complicated just because of that needed consideration as well. And all of these were put on the table to inform the decision at that time. So it's all useful.
Thank you. A couple. Go ahead, Brian, and then Chris, and then Perry.
Thank you, Leanne. So I'll just ask one of my questions for now, and thank you, Zach and Deirdre, for leading this. It's a really interesting discussion. Zach, you partly addressed this already, but I want to be formal about my concern. The world of lead is spiky. It has considerable temporal and spatial variability in new emissions and exposures, with occasional large deviations from temporal and spatial averages. There are hidden legacy deposits in many generally small scale locations. It has important nonlinearities, as you said, in several key relations that are built into your model. There are spiky differences in behaviors that can increase dose to individuals. And there are some vulnerable subgroups, so relying on average slopes with outcomes is a similar problem. And so I was a little unclear and wanted to, sort of formally ask whether you think that the generalized local case study incorporates and overcomes these concerns.
That's a really good point. I think, I'm trying to think of how to answer that best. I think, so if we're talking about an ambient standard level, and I may let Deirdre weigh in then on this also, but I'll take a crack at it first. I think, an ambient standard level, you are fixing a standard level that is, going to be obviously have a shorter period than a year, and you can have various spikes within that. I totally appreciate that. If we're considering even that's annual standard level being different in terms of magnitude than the equivalent annual average, that would be the first question, meaning, are we missing something by taking an annual average equivalent? And that's a good question. And I think even that came up as we're talking here, and I've taken notes on that because I think that's important to consider. I think in terms of individual daily or weekly spikes in ambient air that could be occurring within that, I think, to be honest, I've not thought about those shorter, tighter windows. And Deirdre, you may have a perspective on this from a science policy standpoint. I may let you address those shorter spikier air levels.
So there are a couple of things I would say. Yes, and I remember from graduate school, and it was a whole different topic area. I think it was water quality. It was about what happened. We always use annual averages, but the action is in the episodes. But I think what we face here is limitations in tools of being able to reflect the episodes and know what actually happens as a result of those episodes. And in the air world, yeah, lead is spiky. The particle associated, aspect of lead makes it spiky, perhaps, and the sources in the meteorology. So we don't really have an ability to do day by day exposure, and our modeling tools don't allow us. The IUBK lead model that we use takes annual that's this time step, it's annual. So even if we could, have daily air concentrations, it becomes nothing when we go to feed it into the model. So some of its limitations, it would be great if we could take the day by day variability and figure out what to do with it, but we don't have the tools to do it. But we recognize that it matters in terms of changes, but given that deposition is an aspect of lead, annual average is often utilized for deposition. We just run into thinking about the complexity when we think about dust and kids and household activities, and we wish we had a better tool.
Let me turn this on. So I think the other thing is like with that indoor dust flood model, I think, there is a bit of a dampening of the sort of the relationship between an air peak, I think, and indoor dust flood loading. If you're thinking about that process of sort of cleaning and efficiency, you could have a loading of surfaces, but I think that indoor dust flood pathway to a certain extent, unless you're talking about very massive peaks in air around an industrial facility or something, I think the modeling tool itself and even the nature of indoor dust is somewhat of a dampening thing. That's different than changing a water treatment process and having a very large spike, obviously, in drinking water, or having some paint exposure suddenly provide a very high exposure for a child. So I think it's our modeling tools and even maybe to a certain extent the nature of the air pathway and its linkage to indoor residential dust.
So thank you. So is it fair to conclude that this approach is likely to underestimate population-wide impacts?
How do I want to say that? I don't know that it would underestimate it. I think the point that could there be peaks? Could you think of a conceptual situation where there might be peak exposures in dust lead? I think inhalation obviously could have higher levels of inhalation, but I think inhalation is not driven exposure for the ambient air pathway with lead. So I don't know that I would say that. I think you could envision some kind of peak ambient level that might result in a slightly elevated dust lead, but I think it's unlikely.
Yeah, and I would add, you have to think of the whole train here. And so what do we know about risk associated with, and I'm not sure what you would mean by peak. The CR functions are based on measurements of kids' blood lead, either at a point at the time of the IQ test or, every 6 months over the kid's life from 6 months to 5 years, and we do a lifetime average, or we don't know what that blood lead metric represented, right? It could have been something recent, or it could be just sort of the equilibrium of the child over that time period based on their continuous behavior and a constant source. So I think it's an uncertainty, but I don't think we would say there's a bias low. We just can't say.
And I would actually, the point I would make is if we present risk estimates for a generalized urban case study, we'd have to be very clear that that is not the risk experienced by everybody in a city attaining that level. You could miss elevated air levels. I appreciate that. But most of the time you would have a design monitor at that standard level, and then you're going to have gradients around that are lower. And so, I wouldn't say this is the level. If a standard is set at this level and we have that simulated general urbanized case study, that's really giving you the picture of public health or risk protection or risk impact at that standard level. A population distribution within LA or some other area, if it's attaining that standard, it's going to be a distribution that's lower. And we would probably actually want to be very clear about that, so we're not overrepresenting things. And that's illustrated. If you look at the risk estimates from last time around, you can see the general, we call it general urban case study at that point, but that relative to like the LA or the Cleveland, Chicago, right? You could look at those results and you can see very different mean and upper percentile risk estimates for the general urban case study, much higher versus the city level results, because they're diluted or consider, kids with lower levels of exposure.
I'm going to invite Brissa to jump in because I think she wants to talk about this topic as well.
Thank you, Leanne. You read my mind, or maybe mine. I just want to echo exactly what Brian was saying. I was, writing down thoughts along the same lines, and you articulated it so clearly. I think that it would be a useful exercise to think about how those spikes really do have the potential to bias downward the exposure estimates. Because of all the nonlinearities involved, my intuition is that there is potential for underestimating when instead only the averages are used. Of course, it's a complicated process. But if we think, for example, on looking at the relationship between blood leads at one point in time, which Deirdre just clarified that most of our health effects models look at blood lead at one point in time. But if we instead thought about effects of cumulative blood lead, then a spike in exposure on 2 days will drive up the bloodlets and they will stay up for a few months because that, lead sticks around for a little while. And so then the cumulative blood lead would tend to be higher because of those spikes than would be represented by the average alone. I think that's kind of so in any case, I just want to echo Brian's point, and I think it would be useful to think more thoroughly about those spikes, because as was mentioned yesterday by Perry, I think it was, some of the exposures nowadays are those more spiky exposures. And so thank you. And I also really appreciated your explanations of the various uncertainties involved. I think that's where we are now, much more than before because of these variations. Thank you.
Thank you. I think we're on to Chris now.
So when you say that you're going to prioritize the generalized local model, is that a nice way of saying that that's the only model you're going to explore?
It's the risk assessment that we're aiming to complete within the next number of months, essentially, is going to focus on that risk analysis. I think depending on how those risk estimates, you never know as you put these various modeling elements together, how they come together. I'm trying to think. We wanted to leave ourselves open if we felt that there was a reason to provide a more comprehensive picture. I mean, one thing is, depending on how the standard review goes, you would be doing an economic analysis. Economic analyses nearly always consider, obviously, some kind of more representative characterization of exposure and risk. So I think we wanted to see how those results came out, see probably how they compare and relate to some of the evidence calculations, and also see what kind of also input we got as we start to brief up management on this, and seeing what they felt to a certain extent. But I'm getting a little bit probably over my skis. I don't know, Peter, if you have anything else to add about that. So no, the plan was to do that and be honest about the fact that that's the first for the first draft PA, but follow on, we dependent. I'll let you.
Yeah, no, I agree. It is what we're doing first. And I think regardless of what else we do, we will need to characterize what that means in a larger context. It will give us an estimate of risk for a localized exposure situation. And we'll need to characterize what that means in a broader situation across the country, for example, or across a city. Whether we do that very quantitatively or more qualitatively, I think that's what we haven't decided yet, but we're interested in thoughts.
Okay, so focusing on that generalized local model and assuming that this group would have some input at some point, should it be advisable to do other modeling? We can talk about that another time, I guess. So the main feature of that is that it assumes constant. It assumes that the air lead is at the standard,
right,
and constant. I mean, that becomes a plug-in, right? Does it also assume constant values for example, soil lead and crop lead and all those other things, or does it permit for some stochasticity in those factors?
Right. No, we've in the past, we've fixed all the other levels at representative national levels so that we're sort of saying, for the average residential area, it's not easy to characterize that. But for that, and then we're asking a lot of questions about sort of dialed in different ambient levels for a group at that level. So, we could consider areas that are more heavily exposed. You could consider an urban environment. The only point I would make is that's also likely to push your blood lead levels higher. And you may actually be pushing kids into, from an incremental standpoint, which is the point we were making earlier, you could be, ironically, it's more important possibly to help kids at those higher blood lead values, but the incremental degree of risk reduction from a standard level to another standard level actually could be lower if their blood lead levels are higher because they're on a flatter part of the concentration response function. So it gets kind of strange from a policy standpoint when you look at this. So no, but in the past, we've not defined or applied that generalized urban case study or generalized local case study in different kind of context areas. but we're open to suggestions if folks feel that there's utility in that in future.
Well,
I just want to make sure I'm following, because I thought, and maybe you were going to clarify, I thought you might have been asking about temporal changes when you said, is it held constant? Is that what you're interested?
no, I was thinking more in terms of spatial
Okay.
and the spikiness, both, I mean, spikiness for the terms of air, but that's off the table. You know, the rich data sets from New Orleans and from Syracuse that can give a pretty good sense of the distribution of soil lead, you know, in you know, urban areas anyway, and could be used in a simulation type model to incorporate, you know, a population of homes, a few of which have very high soil lead, many of which have very low soil lead, and you know, to the extent that that helps to create the picture of the variability of the outcomes could be useful. I guess the last thing I'd say is then, regardless of how that part of it goes, it connects then to a CR model, which you're saying you're proposing to focus on 2 sub data sets, one from Boston and one from Rochester. And so I guess I have 2 things I want to ask about that. One is that really the only place in this analysis where at-risk populations are explicitly addressed?
You know, I don't know. I think it's the best IQ loss data sets that we have that look at lower exposure levels. You know, one of those populations is primarily a minority population, a disadvantaged population. The other population is actually an upper, so more SES kind of population. In terms of the slopes and the effects, I think they're somewhat similar, I think. In terms of the unit impact on IQ loss, I may be wrong about that, but maybe that's bounding the reality of sort of the experience of children across the country a little bit in terms of CR functions. I mean, I'll just go out and say this myself. It's a disappointment in a sense that we don't have updated. I was talking to some folks about this, that we don't have updated cohort studies on IQ loss in children exposed at these lower levels. We now have, you know, large numbers of kids in the range of 1 to 5, 1 to 6. And I think we've not recast those studies in a way that would be, and we'd rather be using updated data. A lot of the other IQ data that we found, at least, tended to focus on specialized populations, which are very, very valuable, but often is the reason we're concerned about those populations. They're at elevated blood lead values, so they tend to be a little bit above that range, and therefore, you know, we could consider running some of those CR functions, but they're actually ironically going to be falling in a range of concern for those kids. Let's be clear, but it's not providing a CR function for those lower ranges. And we think that those cohorts from now a couple of decades back are still the best that we have.
Okay, well, I guess editorial comment on my point is it would be a pity, as far as I'm concerned, it'd be a pity to have a document, a process that identifies at-risk populations as an important consideration, and then to have a risk and exposure assessment that doesn't somehow, you know, relate to or address, you know, especially the most, I don't know, obvious and profound of those at-risk populations.
So, yeah, I think we would say children are an at-risk population, and that's one reason we are focused on a risk assessment for children.
Fair enough.
And so, and in Zach can go on in terms of the use of the GSD and getting at different risk factors that might make some children more vulnerable than other children. But in doing the risk assessment, we're focused on the at-risk population of children, and it's consistent with our description of it back in 2008, the at-risk population of children exposed at the level of the standard, which is the highest exposure for the air exposure.
Fair enough, fair enough. And then finally, I would suggest that you explore the possibility, since you're going to be using 2 sub data sets, perhaps using a bootstrapping analysis to generate regression models within those data sets. So bootstrapping within those data sets to create a population of regression models, which then could be used to get you some uncertainty assessment of the final result in terms of the likely decrement, IQ decrement that would occur based on the blood lead levels that the model produces, the IU-EBK model produces.
I mean, so there's certainly to be confidence intervals on the fits of those CR functions, depending. I think at least for one of them, and obviously we want to use that. When you're talking about bootstrapping, can you say a little more about that?
Yeah, well,
Just so I understand exactly.
so if you're not familiar, I mean, I'm guessing you probably are, but bootstrapping would be.
I mean, I know what bootstrapping is, but I'm just
Yeah.
wondering in the context of this.
So you sample the population, create a regression model from that sample,
right?
Apply it, create another relationship, apply it, another.
Are you saying within the context of the study population from Rochester and the study population from?
Correct, separately for those two populations, so that what that'll do is that'll give you then a whole data set of outcomes when you apply the results of the IU-EBK modeling to the CR equation, and then you get a sense of the variability of those predictions.
So you're essentially saying fitting individual regressions to subsets of the cohort.
To bootstrap
functions.
data sets, yes.
Okay. Okay. I mean, we can look into that.
I think Perry's next, and then Phil, and then Judy.
Thank you for a clear presentation. Given that more recent modeling from the EPA has shown a larger contribution to children's blood levels from food, I'm wondering if you're accounting for the airborne portion of the food lead contamination in the model, from fallout onto crops and all that.
So two ways of thinking about that. We're going to be updating the background concentrations on diet. And so we'll be using more relevant or more recent representative values. We don't have a dial linking our ambient air levels to the food concentration. So the food will be reflected as part of their total exposure to fit them on a CR function, but we don't have that. We don't have that. And I'm not sure, I know we've been getting these data, I just don't have them in my mind right now to see whether the background concentrations are now lower for dietary items. I want to say I think they may be lower. And what you may be talking about is the fact that as the air pathway becomes less important as a driver, other pathways increase. And obviously we have the issue of drinking water and lead leaving kids at a higher point in that distribution, sort of recalcitrant. But yeah, so we'll definitely use representative more recent data, but we're not looking at adjusting those dietary concentrations. And that's an uncertainty. It's an underestimate. We were talking about underestimates. One thing that'll be important for us to say is we are definitely underestimating exposure and risk changes by not reflecting changes in ambient air and changes in diet, drinking water, and outdoor soil. I mean, that's clearly going to be an underestimate in our delta associated with going and looking at different standards.
Which is why we have the plus.
Right. So.
I was going to actually circle back to the discussion on the spikiness of exposure, but then Perry, I hit one follow on to yours as well. Two things I think that might be relevant for us is that one thing that comes to mind is a really good study that was done by Ghassan Khoury and Gary Diamond back in 2003 on the RSR facility, which was actually an inhalation exposure kind of modeling exercise. And the whole idea behind that study was to examine this question of short-term variability and the extent to which you could push the envelope on, at that time, the IUBK model, which had a constraint that really, not only are you inputting annual averages, but there wasn't really a confidence around pushing the model below maybe a 30-day window of exposure. So the daily spikiness was really not part of the construct. Fast forward 20 years, we now have the all ages lead model, which has some of the same exposure concepts as the IUBK. And as you say, Deirdre, has been shown to have good correspondence. And there's other members on the committee here that have been part of the all ages lead model review as well. I would maybe encourage EPA to think about as part of your toolbox, bringing the all ages lead model into the picture, at least to address this question of sensitivity around the reasonable kind of ranges of shorter term intakes, whether they be driven by dust or other pathways. So the all ages lead model is sort of designed to do that. The outcome and Cowrie and Diamond 2003 art is one of the papers cited in the ISA now, so everyone can access that pretty easily. The other thing that comes to mind as far as Perry, your good point on these other pathways that might be linked here to aerial deposition and child exposure on a localized scale would be the backyard gardening. So I think the update of the national kind of dietary exposure through the FDA work is a great idea, but it won't capture the backyard gardening scenario. And so that's probably one item to put in your whatever becomes a conceptual site model. And uncertainty is the aerial deposition on leafy surfaces and potential backyard gardening. So.
Just the one thing in sort of response, I think considering the all ages lead model is a more temporally refined model is excellent. I think one thing sort of the take home for us with our contractors after this is to look at our desk lead model and that issue of spikiness and precision and making sure that we're looking at its averaging time, its solution space for steady state and kind of what we're talking about. So is that model a very kind of averaged out fuzzy model, or is it something that can handle spikes and could ask us to look at some of these questions? Because I think this is an interesting perspective that has been raised. I think so. Yeah.
I think Judy, you're next.
You go back to slide 9 on generalized local case study that you point to small neighborhood with ambient air levels at standard and one single exposure zone. Could you elaborate to define the small neighborhood and the single exposure zone?
So it's a conceptual construct, which is, can be dimensioned or parameterized to represent different things. So if we use a small GSD, so we're fixing the level at that standard. So let me step back for a second. One of the questions that we ask with the NACS is the current standard protective of public health? And so we have a current standard, 0.15. Is that level protective? And if we assume, well, if we look at a city that's attaining that, you get all these kids that are below that level, and it's a more complicated question to answer. If we go and we say we have a group of kids right at that level, it really allows us to address that question directly, I think, which is useful. But then to get at your question, we assume a relatively small neighborhood. Looking at the GSD of, I think it's 1.6 that IUBK uses to represent variability, it tends to define that, I think, as a neighborhood where you would expect kids to have similar levels of if generalized exposure is similar, you would have a distribution because of pharmacokinetic differences, intake, exposure, variability differences, behavioral differences, and other things. What are we thinking about in terms of a smaller neighborhood that may have a universal ambient air level, but still include a number of kids such that you would have some variability in behavior? I'm not sure if I'm answering your question, but it's not really specified in terms of size.
See,
it's more conceptual.
what I'm trying to get at is that EPA have specific guideline in terms of for each receptor site. That means each monitoring site, each site they represent some special, zone of representation or zone of inferences. So when you talk about neighborhood,
right,
and that's 0 to 0.5 to 4 kilometer radius from the monitoring site, then you mention, we might look into the urban scale. That's 50 to 100 kilometers. So I'm just wondering that are your small neighborhood referred to micro scale, middle scale, or neighborhood scale of inferences? And then later on the slide 12 mentioned that include many individuals with much lower air-lead exposure. I was wondering, can you quantify that? I'd like to understand the zone of inferences of your neighborhood and how many individuals are you consider for this risk analysis?
So first, the use of terms here is not intended to be the same terms as in the monitoring regulations and the monitoring siting. Zach and I did not consult the monitoring regs in thinking about the use of the term neighborhood. The idea here is simply, and it was at the time, to represent where the idea of thinking about children exposed at the level of the standard, recognizing that air lead is local, that it's drops off very quickly from sources. And so it's going to be a small area. How big is that? How many kids might live there? We don't have an ability to tell you that question. I mean, I guess, yeah, we don't have a good ability to tell you that question, answer that question. So this is a conceptual construct, as Zach said. Yeah.
Jim?
Yeah, hi. I just had, or wanted a little more detail on how you go from the design value standard to the annual average. And are you looking at how many monitors, and are all monitors treated the same, knowing that, a design value is a maximum 3-month value, and that you can actually have order of magnitude difference between two sites meeting the same design value, yet the annual average can be at least, a magnitude difference. So can you explain a little more details on how you would be doing that part?
Yeah, so we spent a lot of time on that last time around and now, and there are a lot of things I've been worrying about recently, technically, and I'm a little fuzzy on the details, but certainly we were looking at, something I may, if you remember details on that. Do you remember the details on this? Yeah. So I'm going to let Deidre, I think she's a little more up on that.
Sorry. So one thing we were aware of in thinking about that is the relationship is going to be different depending on the magnitude of that value, the magnitude of the design value. So we were most interested is when the design value was equal to the current standard. So we wanted to find locations where we had design values close to the current standard. And I think we said something like within 10% of the current standard. And then what is the relationship from the design value metric to an annual average metric in those locations? And it's not a very big sample set, but that's what we tried to do. What's the, I think, I can't remember the number. It's not, as you would know, it's not very many monitors that you have in that situation, but you can tell if you look at the relationship there and then look at it at, 30% of the standard instead of 90% of the standard, it's a different relationship. And so what really matters to us is that relationship when you're at the standard, because that's what we're assessing. I don't know if that's helpful.
Yeah, and then let's say there were 10 monitors. Did you just average them? Is that what you did?
So we looked at the individual ratios for each of those 10, and then do we have a distribution? Are they similar? They were pretty similar. I can tell you had much more similarity when you were at close to the standard than you did when you were well away from the standard. So I think we did take the average in what we've done in our preliminary work, but we've recognized the issue of we want to take a spread perhaps and think about, do we want an average and a 90th percentile or something like that, or the 10th percentile is the right way to look at it. But as I recall, it's not that different.
All right. Yeah, good. Thank you.
Okay, I'm not seeing any new flags up. Have we run the course of our discussion of this section? Yeah, and so as a reminder, I'm sure EPA is taking notes on our comments, but they'll really, the consultation will include a compilation of individual comments. So people should certainly update them or write them from scratch, depending on where you're at, to append to that based on this conversation. If you've got any key points, you want to make sure that they go forward above and beyond this conversation today. And so given we're a little bit afternoon, maybe we take our hour-long lunch break now and then switch to the welfare effects after lunch. All right, we'll see you back in an hour. 20 seconds. All right, looks like a lot of us are back, not all of us. Give EPA a minute to get ready. And yeah, I think enough of us are back. Right. I guess anytime you're ready, we can get started.
Sure. Deirdre Murphy again, and Karen Wesson, the group leader for Ambient Standards Group, is here with me now. Could we get the slides back up? Starting on, let's see, it's probably slide 17, which would be the welfare risk section. And as I mentioned earlier, our lead on the welfare part, Lee Meyer's out on maternity, so I'm doing these slides. And we also have support from our risk modeling group who's helping with this as well, Travis Smith. So, okay. So the first slide is to sort of background, just to kind of ground us in where we were. Last review was 2017. And at that time, the evidence for welfare effects and for information associated with welfare effects, such as bioavailability, fate and transport, all those things that help us to interpret the information and think about relationships between air in lead and welfare effects, did not altogether indicate finding of welfare effects at lower concentrations than what had been reported in the 2008 review, when we had set this standard for the secondary standard, which, as I said, is the same as the primary. It's 0.15 microgram per meter cubed as a 3-month average. The evidence is limited for quantitative characterization of lead bioavailability in the natural environment, and importantly, for relationships between current air concentrations or air concentrations associated with meeting the current standard, deposition, and associated welfare effects, which this challenge is what we face in evaluating and setting standards for deposition-related pollutants. The evidence for such relationships was more limited for the conditions associated with the current standard, which is an order of magnitude below what the standard had been coming into the 2008 review. So it made it more challenging than it had been in 2008. But the limited available information did not call into question. There was nothing that indicated we were having risks associated with that, the concentrations allowed by the current standard. In looking at that, we looked at the information and the risk-related information that was available in the 2008 review. And if we flip to the next slide, this is summarizing, as Zach did on the min exposure and health side, this is summarizing what we considered on the welfare risk side in the 2008 review. And in that review, we had some case studies that were the same for the primary standard and the secondary standard. As Zach mentioned, we had looked at a primary smelting case study. We also looked, he didn't mention, but we did also look at a secondary smelter case study. In both of those situations, we used a combination of dispersion modeling and multimedia modeling and empirical data sets. On the welfare side, we additionally had a case study. Oh, actually on both sides, we had a near roadway. We called it near roadway non-urban, no nouns, I guess, case study, near roadway non-urban, just looking at an empirical data set for concentrations near roadways and information about what air concentrations might be associated with the soil concentrations. Then we additionally, on the secondary side, had a remote area as a case study, which was the Hubbard Brook Experimental Forest, where we had several data sets for several different media that could be useful. We also had a national screening assessment for sediment and surface water concentrations, evaluating those concentrations and considering what information was available with regard to sources of lead to those two different media. We utilized a hazard quotient approach with the media concentrations estimated with modeling and or measurements depending on the data set. The benchmarks included use of ecological soil screening levels and ambient water quality criteria. And we did hazard quotients, the traditional way of exposure over the criterion benchmark. The results across those case studies included hazard quotients both above and below 1, with the exception of the Hubbard Brook experimental forest. The data indicated a potential for increased risk for the circumstances that were assessed. Although the data were not sufficient to assess the portion of that risk attributable to ambient air, and particularly attributable at that time to ambient air that would have met the 1978 standard. And as I said, this challenge became greater in 2016 when we were now facing a standard that was an order of magnitude lower. And some of that had to do with depending on thinking about the different case studies, the National Sediment and Surface Water Screen, you can imagine that the different locations had different sources. So we tried to look for locations for the surface water samples that were not immediately affected by things like acid mine drainage or agricultural input, urban discharges, but it was still complicated to make sure you had one that it's a sticky wicket, as you all will recognize. So those are kind of the challenges that we faced in 2007, but still the administrator felt there was enough information at that time to lower the standard, at least to be the same level as the primary standard. And so now, and then in 2016, the decision was we didn't have something that indicated that the conditions that might be associated with meeting the standard. When we looked at Hubbard Brook, it looked like we could have had concentrations that were allowed by the existing standard, but we did not see media concentrations that were tripping any wires in terms of hazard quotients. So we retained the standard in 2016. And so now going to the third slide, coming into this review and saying, okay, what have we got now? What information is there? What tools are there? Can we push forward in any area? And we seem to come up against the same challenges. And in trying to identify what might be informative that would give us another angle on considering this problem, we looked at the evidence base and said, well, we do have a variety of studies that are looking at trends in the non-air media over time. And this relationship between air and the non-air media is really a hurdle because we want to make sure we consider that relationship. And it's not just kind of a one point in time relationship, it's sort of a steady state relationship you want to have. And so we thought, let's mine those data sets to the extent we can. Do we have air monitors anywhere near those locations that we might be able to consider that relationship? And so that's what we have on the table. That's part of our plans going into this review, is to try and look further. We've identified in the IRP a variety of data sets that come out of the ISA, and we've done some preliminary look to try and identify if there are monitors anywhere nearby, or at least monitors that could be influencing monitors on those locations, and also looking at other sources. Now, that's not completed, but that's what we have in mind to go forward in a quantitative way in this review on the secondary standard. And so as these bullets say, our initial searching indicates that there's a potential for at least some of them to perhaps have some monitors that might be informative on that point. And so the draft PA going forward, as I mentioned at the beginning, the next step is to do these quantitative analyses. We do also qualitative analyses, consideration of the evidence, and all of that goes into the policy assessment. And we'll bring that back to you as a draft to consider. So all of your thoughts now on suggestions on the quantitative analyses are really useful to us going forward. And you'll be able to see what we've been able to do with that advice when we come back with the draft PA. So I think that's where I'd like to stop, and we can go on with the conversation.
All right, it's open for panel comments now. Input, questions. Who's going to go first? How about you?
Okay.
So to organize my thoughts here for a second, I have been confused somewhat in when I read this. And I look back and you outlined very clearly exactly what I thought I'd read, that you know, the studies that were done in, I guess it was 06 or something, and you basically ended up, of those 4 sites, I think it was, you rejected 3 of them because the concentrations were too high. And so I kept struggling in my mind trying to figure out exactly the question that we're trying to answer here. And so it kind of boils down to 2 ways to approach it in my mind, and please correct me. I guess the first question is one way of addressing it is, I'll just state it. So will the 0.15 standard protect the welfare resources? And one day over a beer, we'll discuss where you got welfare. Because I would just call that ecological endpoints, but whatever. Anyway, so that's one way to address the question. And that's is the existing is the existing standard protective of those criteria? I understand that. The other way to ask the question is, what concentration would be protective of the resources? And the way you approach that is different depending upon the approach. And I think, so today, as I was listening to you all earlier, it occurred to me that maybe what you're asking is the first question: is the standard protective? And if I was doing that, I'd probably do what you kind of laid out. Go try to find someplace and see what atmospheric deposition contributes to the matrices that I'm concerned with. And then that makes sense. And so when you look at something like the Hubbard-Brooks study or the other sites that you've suggested, at the end of the day, you're going to have some concentrations in various matrices, and you're going to compare it to something. And so in the past, what you did is I'm glad you put that slide up. You clarified it. You looked at eco-SSLs and you looked at ambient water quality criteria. And that kind of comes back to, I have to kind of circle around to yesterday's comments on the ISA, because the thing I didn't express myself clearly. The thing that I was looking for or wanting from that part of the document was a list of what critters were sensitive, what endpoints were sensitive, and at what concentrations those occur at. And that's what I meant by the synthesis of all of the data. Because if you just say, well, it's causality, it's like, well, causality at what concentration? I mean, it matters. And so to address this problem, you have to have those kinds of concentrations to look at. So if you go out into the media and you go out, you know, you've got air quality concentrations that are meeting your standards, and you go out into the field and you measure sediment concentrations, water concentrations, and soil concentrations, you compare them to the media and you say, good, done and dusted. You know, this is working. But then the question is it too low? Is there, and if the 0.15 is set for human health effects, then okay, you know, you're not going to adjust your environmental one, your secondary standard. You wouldn't adjust your secondary standard because you wouldn't have to. It's protected. So, but if the question is the opposite, what concentration should a secondary standard be? Then you have to go in and you have to say, okay, well, what's a concentration that's protective of sediments? What's a concentration that's protective of water? What's a concentration that's protective of soils? And that's where all of the ISA data came in yesterday and was so helpful as far as that goes. When I looked at it, I thought, well, great, the ambient water quality criteria is 1985 vintage. And they've gone back and they've looked at it basically to check and see if that number's still good. And what you've learned is that, well, there's new things, there's BLMs, there's MLRs, there's all of these things that can change those standards. And that's all really useful information. But once you have that information, you have to ultimately back into an air quality standard. And you've eloquently put it in the text. This is a hard problem because you have air as one source, but if you draw the conceptual model for what these critters are going to see, you've got diet, you've got matrix effects. So all of those things make this a really, really hard problem. So if you approach it by saying, well, is 0.15 good enough? That makes the problem easier, a lot easier. But you can do it the other way. You can go in and you could do something like taking a watershed-based approach, where you go in and you look at all the sources in a watershed and you look at the concentrations there and you predict it, and you could work the problem that way. But it may not be necessary if your primary standard is lower than your secondary standard or whatever. Your proposal to look at the 4 sites, one of them looks at a forest floor, 2 of them are looking at lake sediments, and 1 looks at lichen concentrations at a national park. My fear is that if you get the data back, like for example, the lichen concentrations, what is a safe lichen concentration? Clueless. No one knows. And I won't be able to tell you whether it's going to affect them or how lichens represent the rest of the community. I mean, we just don't have that data for that kind of a situation. If you look at the lake problem, well, you've got air, and air goes to water, water goes into sediment. That complicates it. So you don't know what the air to sediment transfer factor is because you got water in there. I can tell you a way that I would approach it. One is to use an air depositional model to see what the input is. And then I would use something like the ticket work unit model, which is a lake model, which will tell you where the metal is going to end up ultimately. And it's been used quite successfully. It was developed by Kevin Farley and the folks at Manhattan University or Manhattan College, I guess. And it's published and will help you get from air to sediment. And then maybe you could make that comparison. But there's a certain amount of modeling that's going to have to go on. It's not going to be just as easy as, well, we'll go get the sediment concentrations. We'll see what the air concentrations are, and we'll call it good if it doesn't exceed the sediment quality criteria. And the marine environment's not even addressed at all. But maybe it doesn't need to be. I mean, to be truthful, just based on the concentrations. I think that pretty much covers it. Like I said, I would probably approach this using a tiered assessment strategy. Start with the modeling, go to the empirical data, and train your models based on empirical data that you had from those first 4 studies that you rejected, because you're going to have gradient inputs that's going to help you say, well, this is what the concentration is going to be downstream, et cetera, just using the dispersion modeling. And then ultimately you may have to design the watershed-based study and actually go out and do a study yourself, as opposed to waiting on something to show up in the literature, which is, a more proactive approach than a reactive approach. Okay, I'm done.
Well, one of the things we can do at some point in this review is recommend that as a future research topic. So
yeah,
might want to hold that thought for whenever it's appropriate. could put it in the ISA report, but it usually goes, I think, in the PA summary. Other comments?
Could I ask a
Yeah,
question?
go ahead.
Sorry.
Yeah, of course.
First, I didn't catch the author on the lake model that you mentioned.
Farley is first author.
Farley.
It's Kevin
Thank you.
Farley.
Okay, that's perfect. And I just wanted to, two things, just help clarify for anyone. In terms of the question you asked, usually we ask them in the order you ask them, right? We come into review and we say, does the currently available information call into question the adequacy of the current standard? So that's what we come in. If the answer is no, then we're done. It's an easier game. If the answer is, well, we think it does, then we have to go down the second road, which, as you point out, is more complex. So until we get there, we don't know for sure. The other thing I'll just mention is in terms of your interpretation of the ISA, one thing we think about in terms of what we get from the ISA, what we're looking for maybe from the ISA is not simply what effects, it's what effects to what populations at what concentrations. That's what we need out of the ISA. And the at what concentrations has a lot that goes with it. There are different modifying factors, bioavailability, all of that, which helps us interpret it. So we need all of that in the ISA. So I was getting a little nervous yesterday when you seemed to be going down a road of maybe you don't need that in the ISA.
So in response to that, so the one thing that I would love to see that I didn't mention yesterday, and frankly, I didn't think about it until today. I'd love to see a table of the various standards that are available. So like ambient water quality criteria, you put an asterisk there and say, here's what the standard would be at a DOC of what up, and or as high as that. And here is a standard or here's what the PNEC is. Here's what the European folks say. Do the same thing with sediments, et cetera, and then have the results from the ISA, the lit search. So did you find anything that calls to question the SSD that was used to derive the ambient water quality criteria, the sediment criteria, the PNEC criteria? Does that make sense to you? In other words, is there anything that says 1985's ambient water quality criteria, maybe you need to rethink it, and so if you do that, then you have to play by the same rules: survival, growth, reproduction, species that are North American and or are useful. Do the same thing on the European side. To answer the question, are the standards that we did our original evaluation on, the one that you just
The
presented?
criteria.
Yeah, the criteria. So, I mean, that was the hazard question. So the effects side of the hazard question, is there anything from the ISA that makes you think those numbers need to be revised? And if the answer is no, done.
Yes, and that was a point I was trying to make on one of the slides with regard to the 2016 review. That was a question, looking at the evidence, did we see something that indicated effects at lower concentrations? That's what that was referring to. But yeah, well, one question I had too is you said you were worried about, well, you needed to account for the water in between air and sediment. And certainly there are pathways going between the two, but and mechanistically you may want to, but you could also have regression analyses that look at relationships between air and sediment. And as long as you don't have other sources coming in, wouldn't that also be informative?
Yeah, it absolutely would. But I mean, if you use the ticket world model, unit world model, that gives you a time aspect to it. Whereas if you're just looking at a KD, it's like, well, concentration in the water was this, and the concentration in the sediment was that, and we don't know how long it took to get there or how it changed. Whereas these other models give you more of that detail. So the temporal aspect of it.
Other comments from other committee members, panelists? Go ahead, Chris.
So I think the part of Bill's comments that resonated the most with me was the notion that it's not even clear that we know where the most sensitive endpoint is for ecological effects. You know, you look at Hubbard Brook, which, you know, I've worked there for 40 years, and you know, it's tempting to focus on that because there's just so much good information available for such a long period of time. But for all we know, alpine lakes in the Rockies are the place to be looking, right? I mean, and we don't have a data set for lead in alpine lakes in the Rockies. You know, I think Bill's train of thought is a good one in the sense that we may not have data, but we might have enough knowledge to at least do a scoping type analysis to determine whether it's likely that that's a more sensitive endpoint than, say, Hubbard Brook or whatever. That's a big project that's outside of this process, certainly, but could potentially inform future iterations of this process. I will say that in reviewing Appendix 11, that the thing that a lot of things impressed me about it, a lot of things I learned new. I think the thing that stuck with me the most as a kind of an aha kind of moment was the you know, the determination of some ranges for the chronic values for water quality. And, you know, especially if you look at, as I mentioned yesterday, you look at fresh waters with low hardness, low pH, low DOC, you get some bounds on that are really quite close to existing concentrations. And so, you know, if I were going on a fishing expedition, I think that's where I'd probably take my pole first. You know, in your analysis, you would have identified data sets that were relevant to that particular you know, population. But I don't know if some of the USGS data, maybe that from their NAQUA survey, that was running waters though, wasn't it? That wasn't standing water. Anyway, maybe there's some older data sets that are pre-2013 that weren't looked at for this purpose that might be able to shed some light on that. So yeah, so I think, you know, in the case of the primary standard and the human health effects, I mean, we have some endpoints that have been the basis of previous determinations. And so now our question is there a better one? Is cardiovascular, you know, effects, does that now represent a bigger threat than IQ decrements in children? You know, you can kind of do that sort of, is this better than that? But we don't have a place to start. We don't have a viable proposal for what is the most sensitive endpoint at this point. So and that's kind of depressing in a way, but it's also, you know, I think it's a good news story. Lead in the environment is a good news story. And you looked at Hubbard Brook in the last assessment and you came up with a hazard quotient of less than 1 at a standard of 1.5 micrograms per cubic meter. There's no local sources. The concentrations in the air have gone down since then. The standard is now 0.15. I mean, that there's no way that hazard quotient is anywhere near 1 now with that new standard. So I think that might be barking up the wrong tree.
Thank you. If I could just clarify though, in the Hubbard Brook area, the air quality was not just meeting 1.5. We don't have any evidence of that. It's not completely clear what the air quality would have been back when we were bumping that 1.5 in other parts of the country, but definitely it was higher than it is today. That part is definitely true. And if I could just mention a couple of things I forgot for on the research needs, that's a really good reminder that in the draft PA, we do have a section that we always try and iterate research needs. And as you point out, this is a really good area. And I was struck by something you were saying, Dr. Johnson, about the difference in health and eco. And it struck me that one of the reasons is that on the health side, we have this biomarker of blood lead that is universal, or bone lead sometimes. But on the eco side, there's not a unifying factor like that, a unifying metric. And so that does make it more complicated. And the last thing I'll just mention is we talked Dr. Stubblefield mentioned welfare effects and kind of struggling with why not ecological effects. And well, that is a Clean Air Act term. And with regard to the standard is not protection against ecological effects. It's protection against adverse environmental or adverse effects to the public welfare, known or anticipated adverse effects to the public welfare, which we recognize to be a slightly different phrase than welfare. So just a little background, but thank you very much.
So I will ask one more. So when you said blood lead is a biomarker for basically for exposure at a site of action. We do the same thing with pore water concentrations in sediment, water quality. So they're the same kind of thing. You know, they don't necessarily mean the critter is going to be harmed necessarily, but it is an estimate of exposure. It's the same principle. So, and thanks for explaining about the welfare. I had no idea.
This is humorous as much as serious, but this biomarker, with your comments, Bill, if you look at the very, very early Hubbard Brook papers, I mean, the very first ones back in the 60s, their mindset was that the stream water draining a watershed was the blood of the watershed, and that the chemistry of that stream water was the biomarker. Now that was problematic in a lot of ways, and I would hate for anybody to jump on board that particular wagon train, but it is interesting that in fact was the mindset of the early researchers that started that project.
So it sounds like the takeaway from this welfare is that, you know, you may not do anything really different than you did in 2016. You're going to look for whether there's better data, and from what I'm hearing of the discussion, it doesn't sound like there's necessarily, I mean, that how much work is worth it for this task, given what's already been done. Is that a fair statement, or am I misunderstanding something?
I think that I would probably want to do some degree of modeling efforts to start looking at the kinds of concentrations that emanate from various atmospheric concentrations. So, you know, kind of getting a handle on that transfer factor, if you will. Yeah, I mean, it would be a helpful bit of information at this point in time. It is an extremely complex problem that you're trying to do. The separation of inputs that come from non-point source, point source discharges. I mean, you're right. It is really hard. It is a problem that is worked every day, though, by people doing impact analysis at Superfund sites or old mining sites and things of that nature. So it's not like we don't have any experience doing this. We do, but it depends on the question that's being asked. So.
Yeah, and I was just going to say one thing. It's kind of, the issue is working it from one direction or the other, right? And do you work it from having evidence in the environment and try and figure out what role air played? Or do you work it from the other, say, well, we have air, what do we think is going to happen in the environment? And in terms of wanting some modeling, I think we would probably try and look efficiently at, well, do we have modeling that's been done? And what did that show? We could tease out the modeling that was done in 2007, lay that out in a clearly explicit way about what did we predict from these dispersion modeling at different types of sources. We actually, I think at the secondary lead smelter had done dispersion modeling for air, and we had also done multimedia using a RCRA model, but that actually gave us much lower soil concentrations than were at the site, but which sort of made sense if you thought about the site had been there a long time and had historical exposures much higher than that standard, which just illustrated to us again the complexity of it. But we do have those data sets we can lay out explicitly and then think about if there's a new modeling need.
So I guess my comment on that would be that having looked at a lot of field work and looked at a lot of mesocosms and actual field studies and the like, there's an incredible amount of variability associated with those, and being able to tease anything really refined out of that, in terms of a concentration is going to be really difficult. I tend to, just because of my training and because of what I do, I prefer to look at an organismal sort of level. So I take a reductionist sort of an approach into it. I'm sure Chris, as an ecologist, is going to favor more of the field kinds of evaluation. I don't know that for a fact, but I can hone in on an effect concentration, I think, more carefully than relying on the field evaluation. So I probably would start on the air modeling end and assume that my species sensitivity distributions and the like are protecting me and are covering me from addressing the question of the most sensitive species and the most sensitive endpoint and the lowest kinds of concentrations. But that's my bias. So.
So next up's Phil and then Kathleen.
Just a comment, maybe more of a question for discussion for Bill and Chris on the watershed idea and screening level type models. I'm wondering if there's anything that could be beneficial to EPA with fugacity modeling, because that'll kind of help you at least apportion the mass into the different compartments. So if it enters the airshed, over time, the fugacity model kind of gives you a snapshot anyways.
There's a lot of experience doing TMDL kinds of evaluations, which get you at least the water side of the watershed question, and then the aerial deposition you could add in. So I don't know that it's ever been done. I've never done it, but I think it's possible.
Go ahead.
So since you mentioned transfer coefficients, I just want to bring out that we, in California, we have this hotspots program where we do environmental monitoring, and we have developed the transfer coefficients from air to food sources. And so you might want to take a look at that. That was something that we provided when US EPA asked for additional information. So it's in their basket.
Thank you. Other questions or comments from anyone for EPA? Well, looks like we may be at the end of what we need to talk about then. Is that right? Anything else from EPA's point of view?
No, I think we just want to thank you all for engaging with us on this. I mean, at this stage, the planning stage is a kind of a new horizon. So we really appreciate you putting your brains to help us and give us thoughts on this. That's the nice thing about a consultation. It's different than a review in that way. We get to do some real-time thinking on the problem. So thank you very much, both on the health side and the welfare side.
Okay, I think I can, somebody. Yeah, go ahead, Kathleen.
Something I want to mention that on the health side is in the appendix of the IRP volume 3, you have a set of tables here, and it's age cohorts. And I just want to emphasize that although it's not a study like in Haynes, but prior to 1976 or whenever the first in Haynes was started, prior to that, there are smaller studies, at least of adults, that indicate that the average blood lead levels from background was higher than 15. So I just want to point out that there are some smaller data sets that indicate a higher background for exposures prior to the 1975 timeframe. Do you have the reference? Sorry. Do you have the references for those? That would be useful. Or if you could provide them with your individual
Yes,
comments.
I'll provide them.
Thank you.
It's the Kehoe studies
Oh, yeah.
and Griffin.
Good.
Okay, is that it? No more flags, no hands online? I think, oh, George.
The meeting should be over if I can't deal with my sign here. I'm some general comments, not really questions for EPA. Well, I guess they could be, and it's not on the welfare part. It's the,
Whatever.
okay, so it's open mic time.
Go ahead.
Okay.
We're here. We're here until we're done.
Okay. All right. I mean, a lot of these are in my written comments, but there's a few that the panel might want to talk about. It does note in the IRP that the REA will be a supplement to the PA doc, which I know is what has happened in recent history. Not a standalone document, which once upon a time, that's what we did. That actually kind of brings up a bigger topic. I get the impression that we're now working with a somewhat streamlined approach to the review as opposed to, say, 10 years ago. Not necessarily the reviews that ended in 2020, but also not the, let's do 3 revisions of an ISA approach. I mean, are we kind of aiming towards one draft and a final for the major documents? Is that kind of where we're at? Or hypothetically, let's say we were not happy with this ISA. I think we are, but we said we wanted to see a second draft. I mean, is that an option at this in these times?
Yeah, I mean, I don't think we meant to mean to imply that we're trying to, keep CASAC from doing what they need to do, which is, recommend additional drafts when needed. But I think we also all recognize the benefit of doing a good first draft so that we don't have to come back multiple times as well. So I think our aim at EPA is to come to you with a really good first draft and very much hope that we don't have to do a second draft.
Yeah, and I would agree that would be the best approach. And I think, as these documents have gone through, many reviews, they do incrementally get better. The first drafts are better now than they were, say, 15 years ago. So I think maybe we're getting close to that direction. But the big question is document sequencing. I know Jim had some concerns that if we don't see a draft REA until we see the PA, because they're bundled into the same document, if there are concerns, substantial concerns with the REA that might cause it to be revised, but then there's no chance for that revision to be reflected in the PA. I don't, the more new evidence there is, the more likely that's going to be an issue. I don't feel strongly right now one way or the other, but I wanted to raise the topic, and I suspect when I'm done, Jim might have some comments, because I know he was concerned about that in the ozone reconsideration, and actually the 2020 ozone review as well. It's a change from how it used to be done. I'm not saying it's good or bad, but it's different. And then another question related to the REA. At one point in, I guess, the ISA review process, should we talk about if an upcoming REA should include any analysis for an alternative standard? If we look at the ISA and we think, well, is there a possibility that it might support an alternative standard? If we don't get that analysis in an REA, it's much harder for CASAC to, discuss the merits of an alternative standard. So it's kind of a question I'll throw out to the larger group at this point. I mean, I think there is, the possibility of, this ending up with an alternative standard. We're not there yet, but, there is new evidence, some of it stronger. So, but that's a process piece that if we kind of don't anticipate where it might go, it makes it harder to go there. So I don't have a good answer for that one, but I want to throw it out as something to think about and consider, and that both for EPA and for the panel. Oh, let's see. I had one comment, it's a written comment, so I'll skip it here. I think, yeah, I think that'll take care of it. Everything else will be in writing, but I'll resubmit for a final. Thanks.
Thank you. And it looks like Jim wants to follow up on some of that.
Well, I just wanted to second what George said. It really, having a final REA before you start looking at a draft PA, in my opinion, is really the sequencing of how things should go. Because if there are significant revisions in the REA, that could change your conclusions in the policy assessment. And without a final document in front of you, it just makes it really hard to deliberate on the policy assessment. So I'm basically just supporting what George said.
Yeah, and those of us who just went through the ozone review certainly saw the challenges in not having a risk and exposure assessment that addressed some of the questions that we thought should have been addressed. So,
and just a footnote
Yeah.
to that. I mean, if there's not a lot of change going on, I don't think it's an issue. But if there is a lot of change going, or could be, I should say, a lot of change going on in alternative standards, then it becomes a bigger issue. So it all depends on where we think this might go.
Yeah, and if I could just really quickly comment. So yes, in the past, we had very large REAs that were brought to CASAC and reviewed, and we found that very useful. But one of the things that we also found is that there was a lot of time spent reviewing specific analyses without necessarily seeing how those analyses were connecting to the policy, right? So how those analyses were policy relevant. And so in recent times, we have moved the REA into the policy assessment. So it's very clear, like, what is it that is underpinning the policy decision so that you can understand, like, what is it really critical to get right? Right. And so we've taken that approach and found that the advice that we get back is very focused and a little bit more useful. I want to make sure that we clarify, we don't look at that REA analyses as being final by any means. So when CASAC reviews the policy assessment, they are reviewing the technical analyses as well. So if there was something incomplete, inadequate, et cetera, in that REA analyses, then CASAC, we would expect, would advise us to that. And especially if that inadequacy were something that would feed into a policy outcome specifically, we would expect for CASAC to say, we need this revision incorporated, we need a second draft. And so it's a little bit of a chance that we take, right, in putting these things together. But we also have found that it's beneficial because then it's like a clear linkage between the REA analyses and the policy decisions that they support.
That's helpful. And having just come off the ozone review, which was a reconsideration, so the standard process wasn't really on the table. So us asking for a revised version wasn't really on the table. Made all of that, I think it's good to get this out and clear because, having just spent a year going through an abnormal process and trying to navigate every step of the way in a new way, figuring out how to do it as well as possible. It's good to be reminded of what the regular process is and that we have it is part of our role to recommend changes that would, and to recommend an updated document. So, yeah, and circling back to the ISA, I didn't hear anything that would suggest that we think that other than some changes that we talked about, that we need to see it again. And that's something that if anybody feels differently, we should get on the table while we're still in public. But I don't think I didn't see anything to suggest that. Okay. Thank you, George. Good to have the big picture. Anything else? I think now I get to turn it over to Aaron.
Sure, we'll just go over some of the action items. So I'll be in contact with deadlines, but basically, if you're a lead author, you should start drafting up the consensus response and running that by your fellow lead discussants. And those write-ups should be due to me and Leanne by the deadline. But then everyone else, you will also need to revise your preliminary comments on the ISA, as well as your preliminary or your final comments on the IRP as well. So those will all be due by the deadline. So lead authors, you'll need to finish yours before the deadline so that you give your other lead discussants time to review and edit. So those finalized, quote unquote, finalized consensus responses are due to me by the deadline, as well as the preliminary comment or the individual comments. Yes, Chris.
What's easiest for you, since all of us contributed to multiple appendices? One file with everything on it, one file per appendix or per, section? What's easiest for you?
Are you talking about individual comments?
Individual comments, yeah.
I don't think it matters for
Yeah, individual comments similar to what you're, one file with all your individual
everything.
comments, for the ISA, and then one file with your individual comments for the IRP. And then how you organize your individual comments within that file is up to you. Yes, Mark.
Just a question on the on the timing. I mean, it sounds like for the lead authors of the different sections, they would want those individual comments before the deadline because they're presumably going to incorporate them into their write-up, right?
Yeah, to the extent that you're pulling, I mean, the consensus responses are supposed to capture the discussions that happened during this meeting. So to the extent that people's individual comments, they should have brought up all those individual points during the important points during this meeting. So hopefully there's nothing in the individual comments that you have to go back and find that they didn't discuss here.
Right.
And if there is, then you need to email those to the lead authors to help them. Yes, Susan.
So, but the other thing is, when the consensus statement is put together and distributed to the other discussants.
They could say, oh,
They
hey,
could,
you left this out. put
Yeah,
this-
I mean, maybe that's the most efficient way to
Yeah.
do it. Just, it's another option.
Yep. And I sent out a sample report, just, for, in terms of structure, what it's going to look like. So the reports consisted of three major parts: the letter to the administrator, the consensus responses, and the individual comments. So you guys are working on the consensus responses as well as the individual comments. And then Leanne and I will work on the letter to the administrator. And then that whole thing will get sent out to you as well as the public several weeks before the follow-up meeting. And so you'll see the whole assembled report and that will be discussed and finalized during that follow-up meeting, which I think we scheduled for August, late August.
Yeah, it's on our calendars. Several of us verified it last night, but I don't remember at the moment the date of it.
Okay. Any further questions on action items?
Do we have a date for when our responses are due?
I will email that to you after this
Okay,
meeting.
no date.
I'll work through some of the time.
Give us lots of time, please.
We are constrained by the date in August, so. Okay, if that's it, I just wanted to thank everyone for your public service. Thank EPA for all your hard work. Members of the public for your participation, our AV contractors, as well as our meeting contractors. Thank you, everyone, and we could be adjourned.